Good morning. There may still be a few folks trickling in, but we're going to start the session this morning. And we're just going to go right into it. And I'd like to invite Honourable Boyce Thompson, Minister of Agriculture and Land and Justice and Public Safety, to bring some welcoming remarks this morning.
Good morning, everyone, and it's a pleasure to be here to bring greetings from our government and Premier Dennis King. Potato industry has been through a lot in the last number of years. When we look into 2019, one of my first duties on the job was to address the Agri Recovery Fund for the harvest in 2018, and then 2020 we had the drought, and then 2021, of course, the trade restrictions. So our government has always been here for our farmers and will continue to be into the future. We believe that this industry, so much that $30 million in emergency support this year was just a start for this crown jewel of our island agriculture industry that's worth up to a value of $1.3 billion to our economy, spin-off through the potato industry. I believe that between industry expertise in my department and the knowledge of our industry helps us lead into greater places. And these conferences like this are always helpful. We are committed to the agricultural industry. We have lifted the ban on irrigation, so our farmers continue to responsibly grow great food and fair access to water. We are investing in our soil through soil first farming. We are investing in climate action programs because this is the future. People can say a lot of things, but on this island, we cherish our agricultural industry. And we can stand here and I could talk about that all day. The support of our public and our public trust is back in agriculture's corner. We embrace top quality standards across this island. And as farmers, you should be proud of that. As government, we are proud and we want to help showcase that. And I want to thank today Tobin and Kira and Lorraine from the department that will be presenting, and of course Ryan Barrett for his expertise and the work he does for the Potato Board, as well as consults with the department a lot. So enjoy your day, and let's all continue to support our PEI potato industry. Thank you.
Thank you, Minister Thompson. So just so everyone's aware, we've got a couple of sessions this morning. We're going to have a coffee break at 10:30. And then later on, after the conference this morning, you're certainly invited to roam the trade show floor. It's really exciting to be back together in person and be able to put on this event in conjunction with Master Promotions. So we'll go right into it. I'd like to introduce Michele Konschuh from the University of Lethbridge, and she will be giving a presentation highlighting studies in irrigation in Alberta and how it can relate to us here on Prince Edward Island.
All right, sorry, just before Michele starts, I'm passing around a very, very old school CCA sign-in sheet, which is a pad and paper, because I couldn't get the downloadable one to work this morning. If you have CCA, if you're collecting CCA credits, there are credits for today and for tomorrow. So this is for today, of course. Keep passing it around. If you don't remember your number or something, just put your name and email address down and we'll get it from you later. Okay, thank you.
Okay, good morning. Thank you very much for the opportunity to come to Prince Edward Island. It's a little embarrassing that I've worked in the potato industry over 20 years, and this is the first time I've been able to visit the island to see potato production here. We see lots of scenic pictures. We've met colleagues from the island. This is my first visit, so it's been a lot of fun. So I was asked today to talk to you a little bit about irrigation technology for potato, and I'll tell you a little bit about my background so that you understand that this was an interesting presentation to put together, but I feel a little humbled because it's not that I started out with an irrigation background. So I grew up on a mixed farm in southern Alberta, and it was a dryland farm. My parents grew wheat, barley, canola mostly. We had one quarter that was irrigated, and that was in hay. And looking back, I have to say we probably didn't irrigate it, we watered it, and it was supplemental irrigation at best. It was heavier land. And the only place that we grew potatoes was in the garden, and they were knobby, they were a mess. And I actually thought that that's how potatoes grew and that they came with knobs. And of course, you know, you live and you learn. So I went to university, did a PhD in plant physiology, and realized I didn't like basic research that much. I really liked applied. So I did a stint at the U of A doing molecular biology with canola, and started a business, which we did some tissue culture of potato, and then ended up with the Department of Agriculture in 2000 as a research scientist working with potato. And at that time, we just had a big expansion in the industry. And so we had McCain and Lamb Weston plants join us, and they recognized they needed to put a little bit more emphasis on some research to support that industry. So I worked at the Crop Diversification Center South, which is an irrigated crop research center. And the distinction is we worked on irrigated crops. I didn't work on irrigation that much. So I had a colleague down the hall who is an irrigation specialist, a hydrologic engineer, and he, over coffee breaks and hallway chats, kind of educated me about the difference between watering and irrigating. So when I started, we were using hand move, and we used impact sprinklers, and I have to say that the variability in the irrigation with that type of a setup is so bad that it's difficult to find meaningful differences or statistical differences in any of the other research trials. So until you fix the watering, a lot of the other treatments that you're looking at kind of fade in comparison, because water makes that big a difference to the results that you can get. So we've always envied PEI because you get rain, and without irrigation in southern Alberta, we actually can't even set tubers some years. It's too hot, too dry, and we wouldn't be able to have a crop at all. So I learned over time, I'm a bit of an irrigation convert. So one of the things I learned was that watering is not the same as irrigation management. And anytime you include russet Burbank in one of your trials, you get an opportunity to get humbled up. So in the middle of the picture, the one that we cut open looks like a russet Burbank should. It's blocky, it's oblong, and no knobs. We did have an interruption in our irrigation years. These were produced, and secondary growth in the form of knobs are evident. And so this variety will always tell on you at a field day, and it lets your producers know how you did in your irrigation management program that year. So irrigating potatoes is a real balancing act. And if you don't give them enough water, which would be the case for us most years without irrigation, you get low tuber set, you would get poor nutrient use. As a result, you get poor yield. We can also have an increase in some common diseases like scab, early die, and then as a result, you get a poor economic return. If you have excess moisture, you end up with reduced yield because you're increasing disease pressure. They don't like being waterlogged. Potatoes aren't issued a snorkel when they're planted, so they don't like being underwater, and the crop will suffer. And you can also have the potential for fertilizer losses, either through leaching or in the form of runoff off the field. And then if you get interruptions, just like the picture I just showed you, you end up with secondary growth or knobs. You can end up with hollow heart. Sometimes when you reapply water, the tuber outgrows its ability to divide cells in the center and you get hollow heart. You can get sugar ends. That's also sometimes caused by heat. And then as a result, you get reduced marketable yield, which again, impacts your economic yield. So it's a real balancing act when you're irrigating potatoes, and you know that. When you're trusting Mother Nature, I mean, I grew up praying for rain. I imagine on occasion you do her as well. So in Idaho, there's an extension publication that I've noted here at the bottom, and they've done some research to show kind of what happens when you under and over irrigate. So in the center of the graph where they show the optimum, you can see that right around being bang on in terms of the crop evapotranspiration, you're going to get your maximum yield. And from there to a little bit more water, you're going to do great. As soon as you start to short the water, you get into some severe yield losses, but even when you over irrigate, you're going to see some yield losses. So I mentioned I'm an irrigation management convert, and that means I was kind of educated or schooled by the fellow down the hall. And some of the material I'm presenting today is from work that he's done. Probably the biggest eye-opener I had is that I worked with some environmentally smart nitrogen when that first came out with Agrium at that time and now Nutrien. And we had 2 sites for a project trial, and we had several years at those sites. And one site was in Brooks, and in Brooks we really tried hard to irrigate when the crop needed the water. And we had another site in Vauxhall, and that was irrigated when the farm manager thought the crop needed water. And the difference between those 2 sites in the 3-year trial was about 10 ton per acre. And at that time, that was about $1,000 a hectare difference in those 2 sites. And they had the same seed lot, the same treatments, and mostly the same climate. So the big difference between the 2 sites was just the irrigation management. So they both were irrigated. They just were irrigated differently. So it was all about that timing. So that got my attention because I realized in that trial, in the Brooks site, we could say that environmentally smart nitrogen could replace urea. In fact, we could use less environmentally smart nitrogen to replace urea because it wasn't being lost and there was enough water to utilize it. In Vauxhall, what we found was if you don't add enough water to utilize the nitrogen you applied, you wasted your fertilizer. And so in that regard, the Vauxhall trial said that the check treat was not significantly different from the other treatments. You're kidding me. You can't say that not applying nitrogen is going to give you the same yield as applying nitrogen, but if you don't apply water, that's exactly what happened. So that convinced me that I needed to learn some things. And things I needed to learn about in order to irrigate potatoes better was first soil types. So in Alberta, we have many different soil types. Not all of them can be irrigated. On the island here, you're quite lucky that you have sandy loam soil, which is excellent for potato production, and almost all of the island is the same soil type, so that takes one off your list. I needed to learn a little bit about soil water and soil moisture, and about how to measure that well. Also a little bit about nutrient movement and potential nutrient losses. Some on irrigation application efficiencies, and that has a lot to do with the equipment and the technology out there. A lot on crop water use and soil moisture balances, and then also scheduling irrigation. So one of the resources that I was able to use and is available online is the Alberta Irrigation Management Manual. And I think I have a link at the end, and if not, I can provide one to Ryan. It's a 2016 document, but it provides a really good background on things like soil moisture and crop water use and effective root zones and things like that. So if you want some more reading, that's not bad. It also goes into detail on all the different crops. So potato is only one of many in there, but it's a good resource. When it comes to soil types, as I mentioned, you guys are growing on a loamy sand, which is lovely for potato production, and most of the island's the same. At the research centers, I had the luck to work with a sandy clay loam, also good, and it holds a little bit more moisture, which is good for us because with government, we typically have evenings and weekends, and it's hard to get your staff out there to irrigate at that time, although the potatoes don't take weekends. So sometimes that was a challenge. We do have some heavier soils, but as I mentioned, in Alberta, there's a Soils Act, and you can't irrigate on land that's not suitable for irrigation. So they make sure that your land is classified by professionals and that it's documented, and when there is irrigation, it's hopefully going to be using that public resource in the best way on the best land for the best outcomes. And so they're trying to prevent people from fouling up land or wasting a valuable resource. In terms of soil water and soil moisture, plant available water depends on a few things, and a lot of it is soil water holding capacity, and that's determined by your soil type, and also on the effective root zone. And potatoes don't have a very large effective root zone. They're fairly shallow. So about 2 feet deep, you can find roots, or 0.6 of a meter, and that's it. And so it's not like alfalfa. It's not going to draw from water deep down. It's not going to be able to spread out wide. In fact, we did some studies And when you instrument potato hills and furrows, you find out that the potatoes use the water that gets to the hill. They don't use water from the furrow. So if there's water in the furrow, it's either leaching nitrogen under that furrow or going more or less straight down. It doesn't go lateral, and the roots don't reach that water. So anything that ends up in the furrow is usually lost to the potato plant. So that helps advise us on watering. If we're watering to the point where our furrows are getting full, we're wasting water, and we know that now. Plant available water is the difference between field capacity and the permanent wilting point. And field capacity is if you had a heavy rain or you irrigated and you got your soil right full after gravity has kind of taken out any excess water. It's all the water that remains in the soil spaces, in the spaces between soil particles. That's your field capacity, or basically full up, 100%. And then when the water gets drawn down to the point where the plants actually can't remove any additional water from the soil, that's considered the permanent wilting point, and that's when things die. And in between there is what's called soil available water. The difference is that you don't want to ever get to that permanent wilting point, and soil available water varies with your soil type. So we usually use a cutoff, and that would be when we allow managed allowable depletion. And so you'll allow the water in the soil to draw down to sort of 30%, or it's sort of at 70%, but you'll allow it to come down 30 to 35% for potato. And if you stay above that line, you have excellent yields. And what that looks like on a graph is the blue line at the top would be considered field capacity, and the orange line at the bottom would be permanent wilting point, and this dotted red line would be the line that you don't want to cross. The green line then is a trace of your moisture during the season, and on the bottom, on the x-axis, we have irrigation events and natural rainfall. And the natural rainfall are in green because they vary in size a lot more, and the blue ones are the irrigation events. So every time there is a natural rainfall or an irrigation event, you can see the corresponding increase in the green line up to field capacity, and then it will drop back down. And so over time, it drops down. If you're doing an excellent job, and I think this one I might be a real one from Ted, if you're doing an excellent job of irrigation, you bounce between these two lines and you're going to get excellent yield. I'll show you one of mine. It's not quite that perfect. To measure soil moisture, there's a lot of tools out there, and I'm hoping there's some in the trade fair. I've used quite a few of them. Some of them I like, some of them I like a lot less. And all of them work in their way. So one of the easiest to use is to go out and actually, hand feel your soil. And it sounds stupid, but we have some people that are so accurate with hand feel. They're within 2%. If we were to take those samples, dry them down in a lab, and figure out how much soil moisture was in there, we've got a guy that worked with the department for 40 years, and he can grope that soil and he can tell you how much soil moisture is there. And then you get pretty good at it after you do it a bit, and you have some tools to kind of guide you. And there's no real substitute for being out in your field to really check what's going on. So regardless of what tools you use, you should always be able to go out and use a soil auger, like a Dutch auger like this one, or an Oakland soil sampler, and go out in the field and check in the hill and actually hold that soil. One of the favorite tricks my staff has is they don't want to get muddy, so they won't go right into the plot, and they won't go where the hill is. And testing the soil moisture on the edge of the field isn't the same thing, so you have to get muddy. So if you go in and you get a good sample, you can kind of tell where your crop is at. And if your soil is kept at sort of that 70% moisture, you're going to get an excellent yield and your crop won't be stressed. The middle one here is probably the gold standard, the neutron probe. And I had the opportunity to use that when I worked with the irrigation management branch. The downside of the neutron probe is they're really expensive. They're a little heavy to lug to the center of the field. You need to have an access tube installed, and then you go back to that access tube and drop the radioactive probe down the tube, and then you have to have a radiation safety license. So they're really okay for research, really out of range for most growers, but they do an excellent job of soil moisture, and they can also measure at different depths, so you'll get a whole soil profile look. And there's a lot of different soil moisture probes on the market, and a lot of them are meant to make your life easier, and that's the intention. I would say the results on that are mixed. So there's tensiometric methods, and that includes watermark sensors and gypsum block sensors. And these ones sort of emulate what a plant has to do to pull water in. So it sort of measures how difficult it is to absorb water from the water that's in the soil into these blocks. And then there's volumetric water content ones that give you a percent in volumetric water. So they'll tell you what percentage of that soil available water is still available to your plant. And they include things like frequency domain reflectometry, time domain reflectometry, amplitude domain reflectometry, and capacitance sensors. And I've used some of these. Some of them involve like digging a deep hole and putting probes in at different levels. And some of them have data loggers that you put on a stick and hope nobody nails with the dammer diker or the spray truck. And at the end of the season, you can go download the information. You can go out weekly and download the information. Some of them are getting sexier. Now there's wireless devices as well. So there's an article in Spud Smart magazine, I think it was 2017, where Ted was interviewed, and he kind of gives a rundown on the technology behind this. And I won't pretend I understand all of the technology that's involved in these sensors, but I have used some of them. So some of the ones I've used include the DACOM. It's called TerraSen now. It was called Sensetian when I used it. Lovely kind of device. One of the things I liked best about it was it wasn't difficult to use or to install. So you could use an Oakland sampler, make a hole. It comes with a threaded bottom, like a big giant corkscrew, and it comes with an installation stick, and you can corkscrew it into the soil. It makes soil contact. You run a magnet up the side to turn it on. It has a solar panel. It charges itself, and it would wirelessly communicate with my phone. And in 2014, I was at a meeting, the PAA, Potato Association of America meeting in Spokane, and I could sit in the meeting room and determine if my crop needed water and text my technician to address it. And the next day I could tell that he had watered. Oh, it was great. So it was really nice to see that you could use that technology to help you. Sometime either later that season or the following year, we had a little bit of an interruption and it wasn't making sense. It wasn't recording our irrigation events. And I'm like, what's going on with the sensor? We found that if you let it get too dry, and that can happen, then it would lose contact with the soil and it needed to be reinstalled to work properly. They did have a nice web interface. They have a nice app that you use on your phone. So there were some good things about it. But we have one producer who bought, I think, 10 of them. And I think after the first year he tried them, they're all sitting in a storage shed and they've never been used again. And even the ones we had, we tried to use a few years after. We found out it wouldn't work anymore. Oh, there's an internal battery. Once the internal battery wears out, the device is useless. Also, some of them were designed to work with a 2G network. As our telecommunication system changed, your tools are useless. So when you purchase them, you know, that's one of the things that would be nice to be aware of. How long is it going to work for me? Because if you're investing a lot, you want to spend a lot of money on something that's going to last 2 or 3 years or end up in a shed never getting used at all. This CropX one, this is a company out of the US, and they have some really neat things that they've thought about in their situation. I've worked with theirs as well. Again, installation isn't too bad. They do expect you to fill a hole up with water. So you drill a hole, fill it with water, let it subside, screw this thing into the device, and then hope it communicates with you. One of the challenges is there's an internal battery on this one as well. The nice thing is you can charge the battery. The not nice thing is it's in the unit in the ground. If your battery goes dead during the season, you have to spin the whole thing out, take it back to the office to charge, and then you have to reinstall, and you have to go back through the whole reinstallation procedure. One of the things they thought about, which is really cool, is it'll take soil map information. So in our area where soils differ, it will actually find where you are on the map and use the soil information that's kind of publicly available to help you with your management decisions, because it will tell you what your soil type is. And so it's kind of useful. I did have challenges getting it to communicate with my phone, and challenges getting it to communicate in general, because I think that there was a difference in the telecommunication between the US and Canada, and they may have sent me one that was designed for the US. But in terms of installation ease and you know, they have some great videos on their website. It should work really well, and it's wireless. And they do have some external antennas, so if you're not getting a good read, they have an antenna you can screw to the top, and they have another one that has a cord, and you can put it on a taller stick if you need to. So if you're kind of in a low spot, then there's possibilities to kind of address that. This last one that I've got on the picture, Soil Tech, I just got exposed to it last year. It's kind of like a capsule, like a time capsule that you put in your potato hill. And it's got electronics in there that will measure soil moisture, temperature. I think it measured relative humidity, but I'm not sure. And it stays there all season. and it's designed to be harvested. So we were a little worried about damaging it when we harvested. They said, no, it's designed to be harvested. So we're like, all right. And we put it through the harvester and it comes up just like a potato, only it's like a different color, lime, or like very bright yellow. But we found it that way. And then we threw it in our storage, and we just recently sent it back to the owner. So he was able to get soil moisture data for the year, as well as temperature data, as well as some data on our storage conditions. I wasn't able to see the data. Apparently, if he had given me access to the website, I might have been able to track it as well. So that's another thing to consider, is kind of who has access and how do you get access, and also how much can you look at on your phone. So the thing you need to know about measuring soil moisture is all of the sensors work. They all do something. They all have the ability to tell you something about soil moisture that you might or might not be able to tell with hand feel, although hand feel still works really well. The differences in the different types of soil moisture sensors really comes down to how the data is presented, the ease of installation, how sensitive they are, or at what point they fail, because if it gets too dry and they fail, then it's not doing any good after that. Representation of the information, and I'll talk a little bit more about that. Soil moisture content, if it's represented as a volumetric percent of your soil, is great. If you know your target is 70% of volumetric content and it tells you you're at 70%, that's great. If you're irrigating, it doesn't tell you much. You're like, how much water do I need to apply? What does it need? What gets me back to field capacity? So what I prefer with the tools is where it actually gives you a depth, where it says you need to put on 1/2 inch, or you need to put on 20 millimeters, or whatever you need to do to get back to field capacity. Because when you're an irrigator, usually that's how you speak. You know that you're going to run the pivot around, it's going to put on 0.6 of an inch every circle. You want to know that much. Or in the case of my staff, when we were using hunter heads on solid set at one point, we'd have a rain gauge and we would do it for an amount of time, and then we would know how much time. So I would be able to tell them how long you want to irrigate to get the depth you want to irrigate to get your volumetric water content where you need it to be. But sometimes getting a percentage is like, that's great, what does that mean? And so if you're just monitoring for curiosity, it's fine. If you're monitoring as an irrigation management tool, knowing the depth that you need to replace the water you've lost is really important. Reliability is really important. With communication, we've had a few glitches. We worked with one research group that was working with hobo nodes, and the hobo nodes he couldn't get good communication from. So he put in a repeater station, and then they were supposed to tell the repeater station, which would tell the base station, which would send signals to him. It all sounded great, and all season long he fought with it and he could not get it to work until he realized that the producer was having trouble running his pivot as well. And he's like, well, what frequency are you on? And here they were on the same frequency. So the nodes reporting the moisture were actually interfering with the pivot and vice versa. And so those are, things with all the invisible things moving through the air now, hard to know what channel you're on or what wavelength you're using. So sometimes that reliability is concerning. And as I mentioned with the CropX one, we were trying to find the wrong network, and so communication was a challenge with that. So it might be doing the job, but if it can't tell me what it's finding, that's not very helpful to me as an irrigator. Expense is a big thing. Some of them are really expensive to purchase. Other ones are less expensive to purchase, but there's a catch, and you need to have a subscription. And if you have to buy a subscription every year to get data from a device you've purchased, you have to decide that into your management decision making. And you don't want any surprises, right? And if all of a sudden they stop having the subscription, or the business goes under or something, then you've got a piece of equipment that's useless to you. So you need to know a little bit about that. Some of them require more knowledge for interpretation, like the neutron probe. So it works really well, but you need to take a license and have a radiation safety course and a bunch of other things that nobody wants to do. And then you want to know about its life expectancy, like I mentioned with the integrated batteries. The other thing I wanted to just mention with irrigation management is, of course, there's always a potential with irrigation and rainfall for nutrient movement and potential losses. Now, I found the solution. One year I did a trial where we were supposed to look, well, actually it was the 3-year trial with ESN. We were supposed to look at the possibility of nitrogen leaching under the treatments, and we never had one leaching event all year. So if you want to prevent rain, you do a trial on leaching and it doesn't happen. So that was, they were concerned about having that nitrogen move through the profile. Now our soil's a little heavier, it hangs on to the nitrogen a little better, and typically in our area it's so dry that we're irrigating at the top and it never gets to where the moisture is in the profile. So we don't flush nitrogen out because we don't even have enough water to flush it out. So that's less of a concern. When you're irrigating as supplemental irrigation, like here, where you're going to have natural rainfall events, you're probably going to want to stay well away from that field capacity. You have to have some room in your soil profile to absorb the moisture that's coming in. So you want to keep a little bit shy of that 100% line. You want to stay a little closer to 70 if you're expecting rainfall. And that will ensure that your nitrogen hopefully stays where it's meant to be. Of course, there's new tools that help with that as well. So as I mentioned in our trial, you definitely need moisture to make use of the nitrogen you're putting on. If in our area, one of the tools that we use is irrigation, or we do top dressing with nitrogen or other things to try to meter it out so that the nitrogen is available with the moisture at the right time of year for the plants to use it. And so that kind of speaks to those 4R principles, where you want to have your right product, the right rate, the right placement, and the right timing to make sure that the nitrogen isn't going somewhere you don't want it to go, especially at the price of nitrogen this year. You don't want to waste any. So nitrogen or nitrates and sulfates are both susceptible to leaching. So if you have fully irrigated your crop and you get a rain event, you can actually flush that out of the soil profile. Again, potatoes don't have deep-rooted systems, so once it's below that 2-foot level, it's lost to your potato crop. People coming with the next crop, if it's a deep-rooted crop, might be able to do the cleanup act and have a win on your nitrogen, but you don't want to pay to fertilize their crop. You want to pay to fertilize your own. Other nitrogen can be lost through soils. Nitrogen and phosphorus can be lost when soil erodes. So if you have soil running off the field, so again, you want to make sure that you leave some room in that soil profile to absorb rainfall so that you don't end up having any of your nutrients carried away. And there's other strategies. We worked with some biostimulants. I haven't found one yet that's given us a significant difference, but we have worked with things like nitrogen inhibitors, coated products like coated urea products and things like that. And there's some really useful tools out there to help manage your nitrogen and make sure it stays with your crop until your crop is able to use it. So there's other technology besides soil moisture sensors, which really just tell you what your soil has. They don't fix anything. Technology to improve irrigation efficiency includes a long list. Irrigation systems themselves. And so if you're now able to irrigate, hopefully there are people here to talk to you about developing irrigation systems that work for you. I wanted to mention dammer diking. So in Alberta, we do use a dammer diker, and it goes through, or they also call it conservation tillage, and it goes through and kind of makes little pockets or divots down the furrow. At first, someone told me that it was for water conservation, that you did that so that when you irrigated, the water would pool in these little puddles and it would be available to potatoes. But like I said, we instrumented, and there's no way that the potato's going to go 22 inches out over in a furrow and get that water. So we know now that the main reason to dammer dike is so that we don't get channels of water running off the field. So we have a little topography. If you're irrigating, water ends up in your furrow. If it starts to run and there's nothing to impede the flow, it just keeps running. And it's like a drainage ditch. And you don't want that because it carries away your soil, carries away your nutrients, and your water is ineffective in that case. So for us, the dammer diking is really about preventing soil erosion, and it's been a really useful tool for that. And so most of the guys plant and dammer dike. And sometimes the dammer diking is an opportunity. They plant hill and dammer dike, and they might do that a couple times in the season. And sometimes it can take care of a few weeds in the furrow. It can also sometimes incorporate some more nitrogen if they're putting a little bit more down, but hilling's better for that, I think. There's a bunch of different nozzle types. So if there are people in the trade fair that are showing irrigation equipment, there's some really innovative nozzle designs. They include pressure regulators. They try to disperse the droplets so that you get less evaporation. So there's a lot of different strategies that are used. So companies like Nelson has the orbiters. There's companies like Senager with the IWOBs, and they do an interesting job. And they do all of the calculations and the physics when they sell you a package. So if you're putting on say a pivot system, a center pivot system, your nozzles change as you go further out from the center because you have to apply more water because the circle is larger. So you're covering a larger amount of area with the outside of the circle than you are at the inside. So that's important. On the nozzle side as well, I'm going to quickly just show you pictures of MISA, LISA, LIPA, and PMDI. And so these are just acronyms for different types of irrigation sort of arrangements that kind of come with either a lateral or a central pivot. And there's drip irrigation, which is used maybe a little bit more in what we would call farm direct or kind of farmers market production of potatoes, not so much in the larger processing acreage. And some people are experimenting in Alberta with subsurface drip. And we think subsurface drip could work really well with certain types of potato, but at this time, the subsurface drip installations aren't deep enough for potato, and they're mostly used for other crops. But we have people putting in quarter sections and sometimes whole sections of subsurface drip, which blows my mind, because I have to imagine repairing all of those underground things every spring, and it seems daunting. There's also, of course, some really neat technology with variable frequency pumps and drives. So as you move towards systems that are differentially applying water, like a variable rate irrigation system, you're going to need to have systems that ebb and flow in terms of the delivery of water as well. And so variable frequency pumps and drives can kind of accompany that. And then they save you energy charges at the same time. And then, as I mentioned, we have fertigation that we do put on some fertilizer with the water. It saves you a pass in the field. If the pivot has to go around to give water anyway, if you can add nitrogen that way, you can spoon feed your crop through the season. It is labor intensive and a little expensive. I think we've gotten just about as good bang for your buck by using top dressing at hilling and using some of the delayed release fertilizers, but fertigation is still used quite widely. In terms of irrigation application efficiency, at the top of this graph is kind of hand move, what I started with. You're at 60% efficiency, maybe up to 80% if you change the head. So we went to a hunter head, and that was certainly better than using impact sprinklers, but you're not getting very efficient movement, and it's labor intensive. You can kind of go down that list to where you get a traveler, which will be like a wheel move. It's a little bit more efficient, but not great either, kind of 55 to 75%. High impact we had briefly in Alberta. So we had pivots with impact sprinklers on the top, but we lost a lot of that water right to evaporation. So the impact sprinklers would sort of make all these small droplets way above the crop, and a lot of them never ever reached the crop. So the efficiency wasn't great on that one. So a lot of people then moved to low pressure impact, and then what's common now is the low pressure spray. So we have low pressure spray systems. So if you're putting a system in, hopefully you look at low pressure because the application efficiency is much better. They also have what they call bubblers, and that's kind of the LIPA system. I'll show you a picture, and you can get a little bit higher efficiency there again. And of course, drip irrigation is even more efficient, and you don't wet your foliage. So MISA is the mid-elevation sprinkler application. So these, instead of having the sprinklers on top of a pivot, actually have drop tubes. And these drop tubes connect, say, every several feet, and they come down and they hang above your crop, and then they make the water available just above the crop. And so they improve efficiency because they're not putting the water up, 7 feet in the air or 20 feet in the air and having it evaporate before it reaches the crop. So they're a little bit better for sure, and you can get 78% efficiency. And some of these pictures came from the extension website I've noted there. I have some pictures, but they weren't quite as crisp. So the low elevation precision application can be even higher, and this is what they call a bubbler. And you'll notice that these drop tubes are closer together. So they're about 18 inches apart. They stagger, they come off either side of the pivot sort of in a zigzag fashion. And you want to get that water even closer to your crop. If you didn't mind adjusting them, you could have them low and bring them up, but most people don't want to go out there when the crop is larger. You might make a mess of things. And you can get these right down even as close as right to the ground, depending on how much you want to drag them through the crop. I worked a little bit with precision mobile drip irrigation, and this is where you use the pivot or the center pivot or the lateral as a framework to kind of do a combination of pivot irrigation and drip irrigation. So these are drip tubes. So you kind of have a plenum, and we tied it to one of the cross members on the pivot. You have a supply hose that comes down from the pivot junction, and then each of these black lines is a piece of tubing with an emitter. And the emitters are every 6 inches or every foot. So if you need more water to come out, like on the outside of a circle, you have to have a much longer hose. So the more emitters, the more water. And so you end up with this spaghetti, and as you drag it around the field, it just kind of drags through your crop, but it puts the water right on the ground, doesn't wet the foliage, and you get really good efficiency. The downside of this is that wildlife never told them that it's not for them. So what we found was the rodents in our field and coyotes consider it like a large watering station. So they would come up and they would drink water from the emitter, and that's great. And they think if a little water comes from the emitter, if I bite it, I can get more. So we had a lot of time we had to go fix these, because during the season, especially when it's hot and dry out, there would be chew marks and there would be whole chunks of tubing that were broken off. And of course, they don't work like they're supposed to if there's an open end on it. So They get trussed up in the winter to keep them away from wildlife, but it's in the field season when they use them as kind of watering stations that we had some trouble with them. They work, they are very efficient. It's simple plumbing, even I can do it, but there's some maintenance required for sure. And then drip and subsurface, like I mentioned. So in the background here, it has kind of a stylized view of a subsurface drip installation where they used, in this case, it looked like sand filters. There's a couple of different types. Eco Drip and Netafim both make subsurface drip irrigation. They put the tubing in every 18 inches across your field, and you water from the bottom up. And a drip installation is just right on the surface, and that's more like irrigation for nurseries and stuff. So why would we be concerned about irrigation management? Well, the goal is to use water in the most profitable way at sustainable production levels. For production agriculture, generally means that you're using supplemental irrigation, especially here. Increases in fuel prices and energy costs mean that you definitely don't want to be paying more to get that water on the field, so you want to do it as well as you can. We don't want to leach nitrates into the drinking water or waste our fertilizer, having it run off the field. And irrigators want to be scheduling their applications to make maximum use of precipitation they get and reduce any excess runoff. So to do that, you need to know a little bit about when potatoes use water. And potatoes at the beginning of the season don't use a lot of water because they come with a moisture pack called the tuber. So when you plant a seed piece, it has some moisture there, which is really great. Shortly after that, when they sprout, and from then on, they use quite a bit of water. And throughout the growing season, that kind of continues to increase and peaks around sort of when you start to get late tuber bulking, and then it will dive off. So toward maturation, you don't need as much water. And what we found with some studies out of Idaho and other places is that the most critical time frame in order to get great yield is right around when you get tuber initiation. So you don't want to short your tubers when they're forming them, because if you never form them, adding water to bulk them up isn't going to get you more tubers. So you need to have the tuber formation. And last year when we were in the heat dome in Alberta in June, which is really early for us to have 30-degree temperatures, our crop was so stressed it dropped the first set of tubers, and we had to wait for the second set to establish, and then those ones grew up. And we got reasonable yields, but certainly the crop was not prepared for 30-degree heat in June, and we weren't probably prepared to irrigate as much as normal then. I did have a look at WeatherSpark and had a look at kind of just a comparison between, say, Summerside, which I picked out of places on the island, and that's in the green, or sorry, the purple line is Summerside and the green line is Tabor. And you can see there's kind of a reason we grow potatoes in both places. We have a nice climate for that. If you look at kind of freezing temperatures, which is this line, both of us kind of get started around, mid-April. We can maybe get started where we're past the risk of frost. But you guys have a way longer fall. So we already are into the risk of frost by sometimes late September, definitely by mid-October in the Tabor area. Not always, but some years we get caught. And frozen potatoes don't store. They start to rot shortly after they freeze, and they smell really bad. So this nice window here is when we want to be growing potatoes. And you can see with the green lines being, we have higher high averages and lower low averages. And so we have a greater range of temperatures to contend with, but both of us have a really nice growing season. Where the big difference comes in is when we look at precipitation. And again, here, the purple line is Summerside and the green line is the Tabor area. And you guys can count on a certain amount of precipitation throughout your growing season. Looks like the downside is that quite a bit of it will happen at harvest when you probably want to get in the field, and that might be inconvenient and not great for your crop. We have less irrigation pressure or watering concerns at harvest most years, although they can happen. But you can see in Tabor that we just fall short of irrigation or water all summer. And so if we didn't have irrigation, we wouldn't be able to grow a crop. So we usually are irrigating a minimum of 12 inches of water, sometimes as much as 15 to 18. And if we have multiple crops and you have to make decisions, potato gets the water because it's the most valuable crop that we grow. And barley will form some kind of a crop without it, but potato won't. So we don't ever mess with the potato crop. So I know we talked a little bit about deficit irrigation. Deficit irrigation is a non-starter on a high value crop. We wanted to talk a little bit about variable rate irrigation. So it's sexy, and the promise of this technology is still huge. I haven't seen it realized. We have growers that are taking variable rate irrigation systems off their pivot. And I'm like, why are you taking it off? They said, it doesn't do anything for me. And the problem with the technology is something needs to tell it where to water. And right now that something is still people. And we don't have enough trained people and enough information to tell the pivot what to do. And there's a bunch of different research projects where we're trying to solve that problem, close the gap electronically with computers to take sensor information, to develop a prescription, couple it with a map of the field, and then develop a prescription map to tell that pivot where to water. But we haven't actually seen that realized. So most growers do what we call manual irrigation or manual variable rate, and they just determine this section of the field gets some and this doesn't, and they can do that from a pivot panel. So the variable rate technology isn't being used as well as it could be to manage that irrigation better, but the potential is huge and it's still there and we're still working on it. So there's more technology coming all the time. This is what a map would look like. So this is a variable rate irrigation map. You can see the concentric circles on that map would be equivalent to your wheel tracks, the pivot wheel tracks. There's a center pivot in the middle, or the center tower. And then as you fan out from that, there's all these little polygons. And each of those polygons could be managed independently depending on what kind of system you have. So if you have a system that manages zones, it might manage 3 or 4 nozzles at a time. If you have a system that manages individual nozzles, so if you have a sensor on each nozzle, you can turn each nozzle on or off or have it pulse. So it can do different amounts of water on each of those polygons in the field. So in a perfect world, if you have a low spot, you're not irrigating there. If you have a high spot that needs lots of irrigation, you're irrigating there. If you have a really productive part of the field, you want to put the water to it. If you have a part that's eroded, or I don't know, the land isn't as good a quality or something, you can avoid that. You can also avoid things like roads, drainage ditches through the field. You can avoid spraying the end gun on the highway, that kind of thing. So with that variable rate technology, you have the option and the flexibility to manage each one of those tiny little polygons differently. But who has that kind of time? So most producers don't want to take that kind of time, and they don't want to do that if you're irrigating every 3 days or every week. If you're irrigating supplemental, maybe, but this technology has a lot of promise, but it's difficult to manage unless you have some computer help. So there's zone control, as I mentioned, which will manage several zones at once. Speed controls, which will just speed up the pivot as it passes over a whole wedge or a whole section. And then the prescription-based ones. And the prescription-based ones use topography information, your soil map, maybe EC data, to manage each one of those polygons individually. And as I mentioned, there's still research being done to try to smooth that out. So to schedule irrigation, you need to know a little bit about what factors affect your evapotranspiration. Obviously, temperature is a big one. Solar radiation and temperature affect transpiration from your plant. And wind takes a lot of that moisture away from the plant as well. You need to know about your soil available water and your humidity, and then the potential for runoff if you have topography. So because we can't differentiate from water that just evaporates off the soil because it's warm, and water that comes through the plant and is pulling nutrients with it through the plant, we just call them evapotranspiration. So those are kind of coupled together. And one of the easiest ways to schedule irrigation is just to replace your ET. So if you have a way of calculating evapotranspiration, and you know, based on the temperature and the humidity and the stage of the plant and the soil moisture when you planted, how much evapotranspiration you have, then you can just replace that. So this is an example, potatoes in the center here. It's using 0.5 of a millimeter that day, 0.7, 0.8, 1 millimeter this day, 1.5. By the end of the week, it tallies it up. And at that time of year, and this was quite early in the season, this is just late May, they're using 11 millimeters in that week. So if I could replace that 11 millimeters in that week, then the crop is never going to be water stressed. So the simplest way is to have some kind of an ET calculator and just replace the water you use. And this is the simplest for us at the research center. So I can let my staff know, okay, it's hot, it's dry, sometimes we use as much as 1 inch every 3 days. If it's losing that much and you don't replace it, you're eventually going to get water stressed. So that's the easiest way to schedule irrigation, is using a checkbook method. So this method is from the Alberta Climate Information System website. Of course, it's targeted to Alberta. Different areas have different things. There are some online tools. So there's an online ET calculator that I've highlighted here in red. And also, I think the University of Prince Edward Island has some students that were working on a project to develop an app for your phone that would calculate ET, and that would make irrigation scheduling quite easy in this area. So as I mentioned, in Alberta, Irrigation Management Climate Information Network and IRRICAST is how we get some of our information. So you'll need to have access to tools like that. You can calculate it yourself online, or hopefully the University PEI is on that. Another way to schedule your irrigation is using modeling, and modeling is quite effective. So although you think it would be great to know exactly what's happening in your field, sometimes modeling what's happening in your field is pretty damn good too. So it's important to know that your climate can be predicted. We have forecasting, we have weather stations. If you know the crop and you know how it's going to behave, then you can model most of that behavior. And so Alberta has an irrigation management model. It's free as a download. You can run it on your computer. And I think Manitoba has adopted this. So where it would be tricky is you'd have to have weather stations from this area and crop ET curves from this area to make it work. But you can see in here that throughout the season, you can set your maximum allowable depletion line. You can see that field capacity is here. And then your job all season long is to keep that line bouncing between those points. If we have rainfall, which is in blue here, sometimes it'll exceed field capacity, then it drops off quickly to get back down there when you have gravity flow through. When you irrigate, which is the green bars, each time you irrigate, it bumps it up a little, and then the crop will draw it down, and it bumps up a little, and the crop draws it down. And so as that happens through the season, you want to keep those two lines between set points that you choose to make sure that you never run short. And of course, at the end of the season, when you mature, and you stop watering and it just uses up the rest of the water and you're good. So the irrigation management model is very powerful. It's free. Because it's free, a lot of people don't think it's very powerful. So it's bizarre that people want to pay. They want to pay somebody to tell them how to irrigate. They don't want to use free stuff. It's your call, right? This is a phone app that I use. I like this one a lot. So to use the AIM model, I have to be able to download it on a computer. I have to be at a computer. And I don't stay at a computer all summer. Well, maybe now I do, but I didn't when I was growing potatoes regularly. So having this on my phone was useful. And so this phone app can be downloaded from the Washington State University website. It's called Irrigation Scheduler. And the first shot here, this is one of the screenshots, and it gives you a dashboard. And what I like about the dashboard is it has a gas gauge. And the gas gauge shows me when it's green, the crop is happy. When it's yellow, I better be thinking about watering. If it's red, you've already lost some yield. And if it's black, it's dead. Okay, you never want to get near that zone. It'll give me information about, the water today, the water deficit, where I'm at. And if I irrigated, it will show me here. This is an actual shot from last season. Okay, so I had 2021, I was irrigating potatoes. That's June, where we were able to keep up with our watering. This was the first half in June before the heat dome hit us. Even this is color coded. So these are all green because at that time we still had enough soil moisture available. It will show us how much water use we're going to have that week, if there has been any rain or irrigation events, what the available soil moisture is, what our water deficit is. And so in the rain and irrigation column, you can see 0.24 here. I don't know if that was a rain event or if I irrigated, but I would enter that in. It has other cool features, one of which is will show us the soil water trace. So this one shows us the soil water trace. This is your permanent wilting point. Field capacity is up here. And this red line in the middle is maximum allowable depletion. And this was last year. And so you can see, even though I know what I'm supposed to be doing, it's really hard to keep that blue line between those two targets. And so a couple of different times in the season, one here in late June or early July, and in August, we fell below that line. And in August, it was because we had an irrigation breakdown. In July, it might have been because of a long weekend. But when I can pull up one of these, they have soil water charts and other charts. If we go more charts and I go down to the water stress chart, this is a water stress chart. And it will show me every incidence during the year that cost me yield. So it kind of gives you a snapshot as well. But what's nice about this is I can have the same program loaded on my phone as my technician. And my technician can call me and I can tell her how much to irrigate and she will put it in her app and my app, and then we're both on the same page. And so it's really nice. It doesn't work if you have more than 10 fields because you'll get crazy trying to scroll out and scroll back in on all of them, but they do have a website that will allow you to see them all. There's other scheduling technology as well. Soil Tech, as I mentioned, CropX, those were two water sensors I've used. The Light Farm app is one that we're working with a company right now to develop, and we're trying to get something that will take soil moisture sensor from Ensemble Scientific work with it in a computer system to develop a prescription, to send to your VRI panel, to make your watering happen where you're supposed to. And in that process, there's a check-in. So we'd always check with the producer to say, do you want to irrigate or not? And if you do want to irrigate, then it lets your water manager know for your irrigation district. We also have worked a little bit with infrared thermography. So these are infrared sensors that are on a pivot. It takes the temperature of your crop, kind of like we do with COVID right now. It takes the temperature of the crop, and if plants are stressed, they heat up faster. And based on that stress, it's supposed to tell your pivot what to do. The downside is you have to run your pivot dry to get that information, and then you have to go back around with the irrigation. And the challenge is that if you take a day to go around, you're already a day behind watering everything that was stressed. So you're kind of too late on that one. There's another technology here called microwave sensors. There's a little more promise with that. They hang on the pivot as a framework. They monitor soil moisture of the field, and they try to model where that water is required in time for the pivot as it passes over. So that's a little more real time. But again, that technology is still developing. So all of those tools out there, what are potato growers using? And this is a chart from Washington State. And basically, most people are using really simple methods. Now, potato producers might push past this a bit. Most people are either looking at the condition of the crop, using soil hand fill, using a calendar, and then as it goes down from there, that the district determines when you water, or you use ET reports. So even the simplest method, not that many people are using. And you can see here plant soil moistures and computer models are way down the list, and yet those are very effective. So what do I use? So with our research plot, one of our challenges is we have 100 different varieties at the same time. So little rows, many different varieties, they don't all use water at the same time. So we kind of use manual VRI. I have a lateral system that will pass over the plots. I've learned to plant in alignment with that, so everything lines up. If we need less water on one of the trials than another, we can actually turn off stopcocks as we pass the water over. So we don't have to water everything every time. Ours is adjustable by speed. So if we have it 100%, we get less water than if we slow it down and do 50%, where it will move and stop and move and stop and move and stop to try to get the water on. For potatoes, this is giving me watering much more like the producers use. So we're getting yields much like what the producers get right now as well. For us, light frequent irrigations are better for our crop management. Our soil can't hold a lot of water at the same time. So we can do, wax on, wax off. We can put light frequent irrigations, and that works really well. And then we use the scheduler app, and my technician and I can stay on the same page with that. In terms
Michele,
of ongoing, yeah.
Sorry.
Yeah.
We might be getting a little bit short on
Got
time.
2 slides.
Okay,
Yeah.
great. Thanks.
So this one, I just wanted to tell you that we're working with Ensemble Scientific to put sensors in a field. We're going to work with a pea producer this year. We want to instrument the field. We want to work with Light Farm to try to take that information, put it into a computer model, and generate a prescription without a person having to do that work. And then send that to a VRI panel, a Valley system, to try to tell it where to irrigate. And that, as I said, we'll try to let the producer accept or reject the suggestion and let the water manager know. And there's still a lot of technology coming that we'd like to evaluate. So it's not like we have all the answers. We've had to learn how to irrigate. The producers do a remarkable job, but years like last year really challenged them all. And if you guys are irrigating here, your situation is quite different, but I think supplemental irrigation can still help your yields significantly. Those are some resources. They'll be on this slide so you can access them if you like. There's some good publications. Probably the irrigation guide out of Maine would be one that kind of is more like your irrigation situation here. And then there's some other good resources out of Idaho that explain more of the science behind irrigation better than I can. And that's everything I had. So thank you very much.
I think we have time for a couple of questions. Anybody with any burning questions?
Yes, most of your irrigation out west is from reservoirs, is that correct?
That's correct.
Here we have probably 3 different methods of irrigation: by a pond, out of a well, and out of a stream, probably 3 different water temperatures. On a good day with temperatures between 25 and 30 degrees Celsius, the plants can reach anywhere to over 40 degrees on the bottom side. Water temperature going on, what do you see as a factor sometimes in the growth or certain times?
I think the water temperature of the water is still going to be cooler than the plant at that time. And in some areas like Florida, irrigation is actually used not just to irrigate the crop for water, but also to cool the crop. So even if that water is coming out of a surface reservoir or a pond situation, it's still going to be cooler than the crop is. And we haven't seen problems with watering in the heat, but you do lose more to evapotranspiration. So if you're watering when it's really hot out, a little bit more of it will be lost, so your efficiencies aren't as good. So if you can choose, you don't want to water when the plant won't dry out or won't like use that water. You don't want to water at night, for instance, if you don't have to. But we run the pivots round the clock sometimes. So when we're using an inch a week, we can't even stop the pivot. It just keeps going around. So I think the temperature is less of a concern. We do have reservoirs. Some of it's surface canals, but once it gets into that overhead lateral and you're at 35 degrees outside, the water's hot when it reaches the crop, but it's still cooler than the crop is.
Michele, is there any concern? I know a few growers would ask me, like, is there a difference in terms of water, like the effectiveness of the irrigation if the water is cold, as opposed to like if it's warmed up?
Well, I suppose there might be. I don't know that we've done a lot of work with that because we're kind of, you kind of get what you get. But we haven't seen any huge, plant stress or shock from applying water.
Right.
Not like we would if we don't apply it. Yeah.
Any other questions? Questions? Okay.
Okay,
Thank you so much, Michele. And you'll be around the next couple of days if people want to chat with you on the trade floor or that sort of thing.
For my luggage to catch up with me.
Thanks again.
Thank you.
Okay, thanks again, Michele. Our next speaker is joining us virtually this morning from the University of Maine. We have Jay Howe, and he's going to speak to us on understanding the outbreak of potato blackleg and soft rot in the Northeast USA. So this is, it's nice to get some really leading research into this pathogen that we've seen a little bit in the past number of years and some changing information on it. One more thing, if anyone has come in a little bit late this morning, and if you're a certified crop advisor, Ryan Barrett has a manual sign-in sheet if you want to collect the credits. And with that, we're all set to go, Jamie? All set? Great. Take it away, Jay.
Does it display correctly? Hello, can you hear me?
Yep, we can hear you, and everything's showing up on the screen perfectly.
Okay, good.
Thank you, Jay.
Thank you very much for inviting me. I'm very glad to present. This talk is mostly based on my research, and I'm glad that I have collaborated with a lot of Canadian colleagues from different locations, including PEI. I will start. I'm going to talk about this potato blackleg and soft rot. As you know, Maine is a major potato production area. It's not the #1 producer, but potato is number crop in this state. So among those components in terms of marketing, potato seeds is taking a big portion and providing seed sources to the states in the south, or mostly northeastern. Because of that, any seed-borne pathogens or seed problem can impact the growers in the south, and also can definitely have a negative feedback to the local growers, the seed growers. So in 2015, we found frequent report from various states Pennsylvania, New York, New Jersey, Delaware, so forth. They reported that some plant has some problem with the emergence, wilting in the later stage, and rotting. And then they frequently sent plant tubers and plant stems to various labs, including my lab. So we started looking at this, and this is the photo shows one of the examples from Pennsylvania that the growers panicked because of these things. And with the efforts of collaborations, we determined this is a typical blackleg and soft rot disease. It's not a new disease, but it just had a peak time outbreak. At that time, most of the labs were not equipped with the capacity of disease detection. So we were in the same situation. My research interest more focused on fungal and oomycetes diseases. So all of a sudden we have lots of samples, and also we need to determine what's the best way to detect the pathogens. And definitely there's a tension and the pressure from the society, the media, newspapers, TV programs all show those reports, the blackleg, and the impact is huge. Some growers lost their business because of the disease, and then they can't pass the certification of seeds, and then also it results in the shortage of seeds. There's some governmental involvement, and then we started looking at international cooperation. We held some workshops and DICIA summit and trying to solve this problem. And then later on funded by USDA NIFA project, and then we have a national cooperation collaboration on this project. So because we were the major seeds provider in Maine, and also we were the first location find this disease, and automatically a lot of logically people think Maine is the origin of the outbreak, and so we beyond the political issues or any public concerns, so we just look at those scientific perspectives. So the basic questions are, what is the origin of ant species? According to the literatures, Dickia species and Pactobacterium species have been reported, but what specific species is predominant in this outbreak? This need to be known. The second question is, how did outbreak occur? There are some assumptions: climate change, varietal change, or some genetic new strains. The third question is, where did the pathogen come from? Invasive versus indignative. So if there is a irrigation water contamination or seed exchanges, so there are some hypotheses going on, and in the biological studies, we're interested in how do those pathogens survive, because this is a strictly seedborne pathogen. So we were looking at how they survive the storage and through season to season. Those are the questions we are faced on. And my approach of study is a mixture of communication, literature searching, and sample collections. As I mentioned, a lot of samples all of a sudden came to my lab, I receive about 500 samples a year in 2015 and 2016. So because the immediate thing is to how to identify the pathogen, and in the same time, I save all those samples for later analysis. And also we conducted lab and field research, collaborated with other states. So this is interesting literature that I dug out the old literature published from Maine extension article that's back to 1950 when they reported Blackleg and the soft rot. The picture was taken in Presque Isle. On the left side, the photo was also taken in Presque Isle. You can see very similar symptoms, the same field situation. So the earliest report was 1909 by Morse. There are at least 2 or 3 times with kind of severe epidemics or outbreaks in history. And so based on that, we learned some information from the old previous studies. So let's talk about a little bit about the pathogen. So in the disease samples, we frequently identified Dickia, Dianthecula, and Pactobacterium species. Interestingly, over 90% of the pathogens are Dickia, Dianthecula, followed by Pactobacterium parmenteri, but more species of Pactobacterium also were found. So those are all gram-negative bacteria. They can form a cavity on specific semi-selective medium that can separate them from the other bacteria. This is also the mechanism that the bacteria can consume the pectins of plant cell walls that can result in macerated tissues and that cause the soft rot. Historically, the pathogens have been classified, reclassified, depends on the advances of research. Primarily in the old literatures, they were named as Erwinia species. 2 species include Erwinia chrysanthemi and Erwinia caratavra. So the first species were further identified or classified into different Dickia species, as you see on the right column, Dickia parasitica, Dickia chrysanthemi, and so forth. In the meantime, the Erwinia caratavra were classified into different Pactobacterium species. So this is current thing, probably around 20 different species associated with potato. However, each of the species were having their unique characteristics. They have different spectrum of host. Some species, for example, Dickia solani, Dickia atroseptica, are primarily associated with potato, but not the other host. Most of the other pathogens or species have multiple hosts that can bring more opportunities to cause cross-contamination and spread from crop to crop, from season to season, or region to region. So this is a basic fact about the pathogen. We're dealing with many species under 2 genera of bacteria. So in terms of Dickia dianthecula, as I mentioned, this is the only Dickia species that has been frequently identified or detected from the outbreak samples. So typically this pathogen causes lesions on stems, which is called blackleg. Also, the lesions macerated tissues on tubers, which is called soft rot. There is some criteria that you can, experienced people can separate the symptoms caused by Dickia dianthecula and by Pactobacterium species. In the meantime, we saw a couple of storage have this huge problem. The harvested tubers were infected by Pactobacterium parmentieri. So based on those surveys and observations, Dickia dianthecula was more infectious and causing more diseases in the field. And Parmentieri, Pactobacterium parmentieri, caused more storage damage, although both can cause either way. This is a statistics of the samples we have received. So you can see from 2015, we have high number of samples received, and progressively it dropped. The blue line showed the total number of samples, and the orange one showed the Dickia, and yellow shows the Pactobacterium parmentieri. So in the past 2 or 3 years, we have sensed that Pactobacterium moves up and the Dickia drop down. It's kind of a right, but not exactly. This data is kind of biased because as Dickia get well-known and more laboratories and parties get involved, most of the samples were sent to the commercial labs instead of the university research labs. So that's why we have a lower number of samples received. One of the reasons is the sensitivity issue. So the farmers are so protective, they're trying to not express this information. That's kind of a challenge for us too. So anyway, based on the limited numbers, we found that the ratio changes, the overall disease kind of declined. Again, back to the old paper 1950 by Rainer Bond, that he summarized some important points about this blackleg. So on the left side is the literature review, and the right side is kind of current studies. The first one, the blackleg is associated with the fungal or bacterial infections. This is not confirmed from our research. By communicating with the other colleagues, this is not an important factor. And the cutting is very interesting point. They found that long stored cut tubers can be a favorite conditions for the infection. If the tubers were immediately cut and planted, there's no significant infection. This is true in our study, and Stephen Johnson did 2 seasons trials, and he used all kinds of a mixture by cutting, trying to force the cut tubers contact and or macerated and smash the tubers in different ways, bruising, but didn't see any immediate cross-contamination. So probably this is true. I think it's involved in the long-term storage and the survival of the bacteria and some tuber physiological activities. Oh. Also, another, sorry. The disinfection is not so effective This was confirmed by the European studies, and also by my lab research. We show that disinfectants are not the best one, because the bacteria either stay dormancy, or they internalize inside the plant tissue, the tuber tissue, so it's hard to get rid of it. And the literature shows that the insect can be a vector that can transmit the disease from plant to plant. But this is disapproved by INSIGA at University of Maine at all. So they use the lab and field trials and inoculate. They use two types of insects. One is a Colorado beetle, one is a green peach aphis. They use infected plants and then feed the bug, and then let the bug to chew the new plants. They didn't see any evidence that the insect can transmit the bacteria from plants to plant. Yeah, this is a collaboration from the entomology lab and my lab. So this is a disagreement with the previous literatures. However, this is only done with the Dickia dianthigula, because most of the reports were on Pactobacterium. Maybe this is a difference between the bacteria species. So I mentioned the survival of bacteria. So most of the bacteria can stay dormant status if they face a stress. So we artificially provide a stress. We use a copper sulfate to treat the bacteria. So put them in sleep, and then they stay the dormancy status for a long period. So we think if the bacteria are alive, we will see the colonies growing on the culture media. But you can see on this plate, you won't see anything because they don't grow. So this is a dormant state, but they're not dead. By using a specific equipment, flow cytometer, that we can separate the live cells and the dead cells. The red cluster shows live cells, and the green color, the clusters show a dead cell. So can easily to separate which is alive, which is not. So we call those bacteria status as a viable but not culturable, or VBNC status. So on this figure, we can see once they are in dormant status, they can keep at a low temperature. I put this in refrigerator about 4 degrees Celsius for at least several months without losing any viability. So that's kind of evidence that the bacteria can survive on the tuber or inside the tuber until they were brought to the field. Then they can start moving up through the vascular system and cause wilting disease. The bacteria also has mechanisms in terms of pathogenesis. They enter the plant tissue through natural openings and wound tissues. They secrete various types of chemicals, including adhesions, effectors, biofilm-related chemicals, pactolytic enzymes that can degrade the plant tissues, and quorum sensing related signals. So those chemicals can be delivered from bacterial cell out of the cell wall and either move onto the plant surface or deep inside the plant cells. So the picture shows the directions that bacteria move out through one of the secretion system and then inject into plant tissues. So they can use a various type of secretion system. We call the type 1 secretion system, type 2 secretion system, type 3, type 4. At least 4 of them are involved in the pachylytic bacteria, or particularly the pathogen causing potato blackleg and the soft rot disease. So different system can deliver specific chemical or compounds. So those are required for pathogenicity. We mentioned the bacteria in Dickia danthicla and Pactobacterium parmentieri. These two species have a different performance or activities against various plant germplasm. So we picked one potato variety, Lamoka, which is more sensitive, susceptible to bacterial infection, and caribou russet, which is more tolerant to the infection. You can see the combination that the plant has different responses. By the way, this caribou russet is a newly released variety from by University of Maine. So it's got very popular now. And fortunately, we found this is a good variety for resistance against Dickia and Pactobacteria. And the two species, Dickia danthicla and Pactobacterium parmentieri, are associated if they cause a certain level of disease lesion. The other species have a similar situation. So this is a correlation we can find. So if you look at the left corner, this is the caribou russet. That's the most tolerant variety. So I like to bring this diagram. This is a disease cycle generated by the Canadian colleagues, Dr. DeBoer. Just want to show that this disease is a seed-borne, started from the seed and can cause a seed decay, and also the in-season infection, and then ended up with the next generation tubers infection, and then come back to the tuber. So this is a typical disease cycle. And we follow this disease cycle. We did some epidemiology studies. One thing is interested in diagnostic procedures and disease epidemics studies. That typically we want to collect the small, for detection purpose, we collect the piece near the stem end, because this is a pathogen that connected the vascular tissue. So the stem end is the part of the connection. So this is supposed to be the highly populated area. That's how we collect samples. But with two studies independently from my lab and from Gary Secor's lab in North Dakota State University, we found that some other areas also have high population of bacteria. So the black number shows a Secor's lab result, and the red numbers shows my lab result. The difference is we were 5 months apart. So my result was derived 5 months later than his. This can probably show that as the tuber stay longer in a storage, the overall bacterial population decreased. So this gives us important information. The sprout is active area that can bring the bacterial population up. So this is useful for both detection and production. And back to the outbreak, I mentioned that the northeastern region are related with the outbreaks, and we found Dickia dianthecula as a predominant species, and also followed by Pactobacterium parmentieri. The other states are trying to isolate or detect. They found some Dickias or Pactobacteriums, but they're not so important. Most likely just a volunteer or some opportunistic species. So it's still focused on this eastern area. So we're gonna further look at those Dickia dianthecula, what happened. So by analyzing the pure cultures of different bacterial isolates, we find using the PCR-based technology, we found the 3 groups from the population based on our isolation. And those 3 groups, we use a different DNA sequencing analysis and establish phylogenetic trees. Also, corresponding the box PCR result, they are clearly showing 3 clusters of population. So we give them genotypes name as a genotype 1, 2, and 3 for further studies. And by looking back to the 2015 or through 2019 samples, so those samples are just mixture from the disease tissues, and it can consist of everything. So we use those specifically designed primer that can differentiate type 1, type 2, and type 3 Dickia dianthecula. We found type 1 is predominant throughout the seasons, throughout the states, especially in Maine. Type 2 appeared in the first year, 2015, and was not detected in the following years until 2018. And type 3 never existed in Maine. And so we found this is very interesting. Based on this, apparently the type 1 is predominant population. So the Dickia dianthecula, the species can be differentiated into 3 groups, and then they probably have a different history based on this distribution. And then further, we use the phylogenetic, the whole genome analysis. We identified the worldwide populations. We found 8 clusters. This is a analysis of a worldwide collection based on the gene bank database. We found those orange colors, clade 1, 2, 3, exactly correspond to the genotype 1, 2, 3 in United States. So those are just USA specific. They're not connected with the other countries' clusters. So that just separated, this is the USA strains. Okay, let's go back to the Dickia diathecula, the 3 genotypes. Because of that, we were interested in what makes these 3 genotypes unique and different. So we picked some of important functional genes like secretion system, enzymes, and pathogenicity related genes. So we found that in type 4 secretion system, as I mentioned, that can secrete the chemicals through the bacterial cells and pump into the plant cells, that the clade 1 or genotype 1 has an extra copy of the cluster related with the type 4 secretion system. And for type 6 secretion system, the clade 1 and clade 2 have extra copy of the genes. So that means they have additional gene copies that indicating more effective and more aggressive in infection. So probably from this genomic study, it partially explains why clade 1 or genotype 1 was predominant. And
Jay, can I interrupt you just for a second? So we're just starting to get a little bit short on time. And
Okay.
I want to save a little bit of time for our primarily grower group here to ask some questions. So just, I'm not sure how many slides you have left, but just I'll give you a
a
heads
couple,
up.
yeah, almost, yeah, I can go quickly. Okay, sorry about that. So I will go, so we dig out more Pactobacterium and species. We found all those are pathogenic from the samples we isolated. And more importantly, we surveyed the water system and we find several isolate that can be pathogenic to plants. You can see this Dickia aquatica. This is not supposed to be a pathogen, but from our culture, this is more aggressive than any of the other, like Dickia diathecula and Pactobacterium palmatieri. So this is a kind of a concern or potential risk. And we compare in different concentration, also show the Dickia aquatica is very aggressive and pathogenic. So this is different with the European studies that they show that aquatica is less important. Maybe it's just different. And one more slide I want to show that when the Dickia and Pactobacterium separately inoculated plants, they cause different levels. The Dickia is more aggressive. However, if we combine them, they are more aggressive than any of the individual inoculation. So that's why we saw the disease probably caused by a mixture of the species. So I guess this is my summary. Multiple species cause the disease, and probably one genotype is a predominant species population that explains the outbreak. Water can be a contaminating source, so we have to think about that in the future. I will just acknowledge my collaborators and funding resources, and we'll stop there.
Thank you very much, Jay.
Thank you.
So I have one question before, this is Ryan Barrett here. I have one question before I hand it over. So we haven't seen Dickia very much, if at all, here in PEI, but we are seeing a little bit more blackleg symptoms, I think, that are more on the Pactobacterium and these changing Pactobacterium species. And it's interesting that we're seeing more blackleg that's showing up later in the season, as opposed to like traditionally a lot of blackleg, it would show up after emergence and you'd have poor emergence and those plants would die. And now we're starting to see blackleg that stays more into adult plants, and those plants are able to make tubers, which are then able to make more infected tubers that go into the storage. Can you say anything about, this new, like, Pectobacterium parmentieri, it's aggressive, but does it tend to be more aggressive later in the season as opposed to early in the season?
To my experience, Pectobacterium causing more problem in the storage. So it's also not a strict seedborne pathogen. It can stay or survive better in the soil. So it has more chances to infect tubers, but it's in terms of pathogenicity, is less aggressive.
Okay. Thank you. Any other questions? Any questions from anybody here? Okay, if not, thank you very much, Jay. We really appreciate you taking the time to join us.
Thank you very much.
Yes, thank you, Jay, for joining us this morning from Maine. So that concludes our speakers before coffee break. We're scheduled to have a coffee break until 11 o'clock. And at 11 o'clock, our next speaker, Lance Stockbrugger from Saskatchewan, is going to join us. He's a farmer. He's going to talk to us about maintaining profitability in times of increased costs. And so I think even though we're a little bit run behind, I think we'll start again because the trade show is not open just yet. We do have coffee and water and everyone can take a break for a minute, but I think we'll get going right at 11:05. So thank you.
And if anybody came in and they didn't sign for CCA credits, let me know and I'll get your credit or you get your CCA number.
Okay, I think everyone is pretty well back in the room. So we'll start with our next speaker, Lance Stockbrugger, speaking about profitability through management. Thank you.
Well, thank you. And thanks for having me at your conference. It's, as I walked into the room, I realized I've been here before. I've been to the island a couple of times and spoke in this room probably about 5 years ago, and it's been almost 2 years now since I've been able to do this live, and I'm glad that you guys are able to have your conference. When I told everybody out west that I was coming out to speak at a potato conference, they said, "What the hell do you know about potatoes?" And I said, "Well, I know they make mashed and fries, and that's about it." And today, so I'm not going to pretend to know lots about potatoes, but I'm going to pretend that I know hopefully lots or some about management and profitability and financial. So just a little bit of background around my, because I think this helps set the stage of where I've gotten and why I think the way I think. This is the farm as I knew it when I left it in 1991 to go to university. It was homesteaded in 1909. There was a yard, you can't really see it because it burnt down and was destroyed in 1939. And my mom and dad started this yard in 1977 when I was just 4 years old, moved out there and my mom and dad were in a car accident and my father was killed in 1984. And growing up, I knew that I wanted to farm. That was what I was going to do. I followed my dad. I did everything. I slept more hours in the tractor than I did it in my bed. And so my life was devastated in 1984 when we had to rent out the farmland and sell the equipment. But I always knew that I was going to eventually get back to the farm. And in 1994, that became a reality for me. And so now I've been farming for over 25 years. And so basically, I think I consider a third generational farmer, but really a first generational farm that I've started, other than on some land that was acquired from my parents. So in 1994, we started with 1/4 of farmland, seeded it into wheat and canola. That picture there was my first tractor. Still have it on the farm. It's one thing that we've put up for sale a couple of times and I just can't bear to let it go. And so it's still on the farm. I paid $5,300 for it at an auction sale, and I also bought a combine that year as well. I remember that night going home and laying in bed, and I'd spent, just shy of $8,000. And I'm laying there thinking, how am I ever going to pay that money back? What was I thinking, spending that kind of money and, just starting out farming? And so I got a loan and I learned how a loan works and how the interest rates work and how you pay it and things like that. And so starting off very gradual, and that's sort of been the basis or how our farm has progressed, is slow and steady growth. I was farming with a neighbor at the time. Right after my father passed away, he came and asked me to help on his farm, and I worked for him for 10 or 12 years. And so that was also how I got started into the farm, is using his equipment to get started and then slowly adding this up. We also had 5 bred cows and calves. We thought that was going to be the way that we were going to make money, was with cows, because every year you breed a cow and then she has a calf, and it's literally like just money falling on the ground almost. But soon we realized that that wasn't the case, and we do now get some, I call myself a fair weathered cattleman. I buy them in May and sell them in October, right when all the work has to start. So this is our farm now. We're up to 4,000 acres. We grow wheat, canola, peas. If phytomyces is a big problem for us in our soils with the wet ground that we've had. Now, having said that, last year was a complete drought, one of the worst droughts we've ever had. So hopefully that's going to deal with some of the disease issues we have, and barley. So what have I learned over the time? So most people would think that if you wanted to be a farmer, after high school, I said to my mom, I said, I'm going to start farming. And she said, no, you have to go get an education. I don't care what kind of education you have to get some sort of an education. Most people would say, well, if you want to be a farmer, you'd go into agriculture. Well, I never take things the easy way. I went into business. And the reason I went into business was because I thought that might be something that could add to the value of the farm. And it was something that I really enjoyed. So the education gave me a lot of opportunities and a lot of benefits to think about how to run and start and manage a farm. After I got my first work term at university, I got a job at a chartered accounting firm. And I really liked the work. I enjoyed it. And I looked at their time schedule, and they were the busiest during the winter months. And so I thought, well, this is a time that I can work with the farm, with a grain farm in Saskatchewan, is work throughout the winter months doing tax returns and planning and things like that, and have a quieter, easier time to get away from the farm or from the business and spend it on the farm. So I pursued that career. I wrote my chartered accounting designation, and I started working for PricewaterhouseCoopers at the time. And I soon started to accumulate clients. People started coming to me saying, we want you to be my accountant because you understand and live and breathe agriculture. So you know exactly what we're going through, what's impacting our farming operation, and you can help us. So I started building a client base, and it soon realized that if I was going to work for farmers, there was one thing that I needed to know a whole lot more about, and that was income taxes. Because farmers want to have nothing to do with income taxes. They don't want to pay them, they want to avoid them, they want to do everything they can. So I needed to understand the tax system as much and as good as possible. So then I ended up going in and doing another 3 years to become an in-depth tax specialist. And that's where I spent my career with PwC, working in their tax department, focusing mostly on agriculture. 2012 came along, and we had moved to the farm. My wife and I and the 2 boys had moved out to the farm, and I had said I wanted to quit farming in 2010, quit working and focus just on the farm in 2010. And in 2010, we got 38 inches of rain that growing season. Now that might not sound like a lot on the island, but in Saskatchewan, we were literally flooded. We had water everywhere. The crop was a disaster. We could only seed about half of our crop. So I realized, well, this realization of quitting my job is not going to probably happen. So I continued on for another couple of years. And since 2012, we had some really great production years, with the exclusion of last year where we were hit with a significant drought. But over that time period of working for 20 years and working with clients, I got to gain a lot of experience, a lot of knowledge from them. Because I was just a young farmer starting off, I couldn't afford, I didn't have a lot of equity in the farm that I could afford to lose or to gamble. So I had to learn from their mistakes and learn from their best practices. So I tried to combine all of the things that I learned from them and focus it on our farm and build that to make it a better operation and more successful. One thing that I've learned as well, I guess multiple things that I've learned, is relationships. And I'll talk more about that in a moment, but relationships with our suppliers, our customers, and our landlords. All 3 key aspects of our business and running our operations that I think is very important on a long-term basis. And then I want to talk about minding the pennies and the dollars will look after themselves. And that was a quote that an office manager told me at PricewaterhouseCoopers when I was working there. I was working late one night, and I'd gone down to the coffee room and I wanted an iced tea. and I noticed that there was no iced tea in the coffee room. So that night on my way home, I had to stop at Walmart and pick up some supplies, some groceries or something, I don't know. Anyway, I saw iced tea was on sale. So I grabbed a bucket of it and I took it to the office next day, put it on an expense report, and was expecting to get reimbursed for it. Down comes the office manager stomping down to my cubicle and says, "Why are you buying iced tea?" I said, "Well, because the coffee room was out and I wanted one." And she says, "That's not your job." I said, "I know that's not my job." I said, "But I thought I'd help you out and it wouldn't be that big of a deal." And she said, "I can buy it a lot cheaper." And I said, "Well, it was on sale," and on it went. And finally she said to me, she says, "Through our suppliers, we can buy it $2 cheaper, $1. I don't know what it was." But she said, and I kind of looked at her like, "You're nuts, lady. We're arguing over 50 cents. And she says, "If you mind the pennies, the dollars will look after themselves." And I was too young and naive to really know what that meant until I really got into my business. Then I started to realize that every business transaction, everything that we talk about and think about when we're working on our farm needs to be analyzed, I think, and needs to be looked at. No expense is too little to just be ignored. Now, I've changed my mindset a little bit since profitability has been better and our farm has grown, and I need to focus on things that are important. But that was one of the guiding principles that started off our farming operation, was thinking about every transaction that we were doing and how we were spending it. So building relationships. Our customers, people that we sell our product to. As a grain grower in Saskatchewan, we're a bulk commodity. We sell it to the highest bidder, basically. But I like to focus on our farming operation to be a little bit different with our suppliers. I have customers, and I respect those customers. My customers are the grain companies that buy our product. And I basically deal with 3 or 4 main buyers for different commodities. I sell most of, if not all of our wheat to a miller in Saskatoon. I truck it into Saskatoon. I go a lot farther than a lot of people who are willing to truck their commodity. But I have a very good long-term relationship with these people that they know exactly what they're getting when I bring my truck in and I'm going to deliver it. I no longer have to send in samples and get them to analyze it ahead of time. If I say, "This is what I've grown, it's number 1 wheat, 14.5 protein," they know that when it shows up, it's going to be number 1 wheat. And the protein might be a little bit different, but they know that I'm not going to try to snowball them or lie to them and bring in something that's not. And so that long-term relationship that I've got with them has usually given me a premium. Very rarely do I ever accept the price that they're posting. I phone the grain buyer up and I ask them, and I say, "This is what I've got. This is how much wheat I have to sell. What are you willing? I'll deliver it when you guys want it. So you tell me when the delivery periods that'll work with my schedule, and let's figure out a price that works for both of us." And usually, I'm able to derive a little bit better of a price than that's just the regular posted price. So it's a two-way street with them, in that they know what they're getting from me and they can rely on my delivery. When I say I'm going to deliver on March 29th, I make sure that I'm there on March 29th because I know that they need it that day, and they know the quality that they're getting as well. We also, for our canola, we sell a lot of it to Bunge. We've enrolled in a sustainable farming practice program with them so that they can ship that commodity out to Hamilton, Ontario, where it's crushed and made into specialty oils. And that's as well given us a bit of a premium over the posted price. Now, it's open to a lot of farmers, but some farmers just don't want to bother going through the hassle of doing it. But once we've done it, we're able to stay within that program. And as long as we continue to do those practices, and they check it every once in a while, there was an audit in the last 5 years that they had to come out and check certain things that we were doing and making sure. And it wasn't erroneous. It's nothing crazy that we have to do. It's just a lot of good farming practices, watching rotations, how we treat our chemicals and things like that. And so treating our customers like they want our business and we need to earn their trust is very important to me. I think setting your farm apart from other operations, making them understand what's different about your operation, or how do you run your operation to make it more valuable to them? Is there ways that they can add value to for their end customers as well? And this goes through the timeliness and the quality and the quantity, which I talked about, making sure that what we're growing is what we're delivering, and being upfront with them, not to try to snowball them or sell them something that's not right. I sit as a chairman on one of our local terminals. It's a grower-owned terminal, and we sit and I hear all these stories, not always, but quite often. Once a year, there's usually some farmer that's trying to bring in grain, that he's hiding it in his load, and then they're discovering it afterwards. And usually they can trace it back to know who that is, and it damages their relationship. If you have something like that, in my opinion, then be upfront with them, deal with your buyers, and know that you need to deal with it. That's what the commodity you've got. That's the problem you have. Trying to hide it or get accused of it later is not going to help your operation in the long term. Suppliers. We need them just as much as they need us. We need to make sure that we've got our goods that we need coming in regularly. And just as I landed in Montreal yesterday, I got an email as I turned on my phone from one of our a supplier, and it's a chemical supplier. And him and I always banter back and forth about high pressure sales. He's always sending me an email saying, these are the high pressure sales. And his high pressure sales are, we're on allocation. We've only got this amount. I need to know, by tomorrow type of thing. And right now I'm very uncomfortable and I'm way out of my comfort zone in terms of trying to deal with our chemicals. But I don't know if I'm buying into the rumors or not that there's going to be a shortage. And he's telling me that there's a shortage and prices keep increasing. And one supplier that we're dealing with won't even give me a price until it's landed in his shed. And he's been invoiced because it changes from the time of when it gets shipped until it actually gets invoiced. And so it's a pretty frustrating time. But knowing that I can trust those suppliers and that they're acting with my best interest in mind, and selecting and working with only a few suppliers, I think is key. Just last week, I was talking with a farmer who had booked all of their fertilizer in October with, I'd call them a hay shaker outfit for Western terms, but a small supplier that doesn't have a great reputation, but had a really good price. And I just found out last week, he admitted to me that that product isn't showing up. And now they've had to go to the market and buy it at probably 3 times the price, maybe even more than what they were expecting to be paying at the price from that other supplier. And so having a relationship with someone like that obviously is not very good. And what's that going to cost that operation? This is a large farm that is buying thousands and thousands of tons of fertilizer, and they are going to be significantly hit because they tried to save a few pennies. And I understand saving pennies and saving dollars is important, but what's the long-term effect of having those type of relationships? So knowing that we need to make sure that the suppliers stay in business as long as we stay in business, and that we might not be able to always get the lowest price, but that we're treated fairly and we can trust that we have with them, the relationship we have with them. So minding the pennies. Every transaction, not every, but most transactions have to have a return on investment. I drive a lot of our suppliers a little bit crazy because I'm quite often asking them, well, how is that going to impact me? Last week, we sat down with our variable rate fertilizer suppliers and talked about our soil samples and our how much fertilizer we're going to be putting on. And now, because of the drought, we've got a significant bank in the soil right now. We've got about 30 or 40 to sometimes 50 pounds of nitrogen. And I know that doesn't sound like a lot out here, but for us, that's a huge bank because we're usually putting on about 100 to 140 pounds, depending on the crop, of fertilizer. So we almost have about a third of our fertilizer, a little bit better, in the ground. And so we're talking about fertilization. Now, parts of Saskatchewan are still significantly affected by the drought, and we're not out of the drought either yet, but literally we've got feet of snow in Saskatchewan. We've had track hose and cats pushing back the roads. It's like you see in the old days in the 90s when they had the train going through the tunnels of snow. That's pretty much where we're at. So if we get a good melt, and so far it has been a good melt, we're going to start off with a good soil moisture base, but still we need the rains in June and July. So there's a lot of discussion about, do you use the fertilizer that's in the ground to get it started and then top dress later on? Do we put it all down right away because of price and availability? There's a whole bunch of discussions about that. And so I was really challenging the agronomist saying, okay, well, what's my return on investment? How much, I know the likelihood of the rains and we have to consider that all, how that's going to affect the utilization of the fertilizer, but how is that going to, where's my law of diminishing returns? Because if I've got 50 pounds already in the soil and I add another 100 because I've already got it pre-bought at a good price, is that going to get me a huge return? And because of the commodity prices that we're dealing with and looking at right now as well. So those are the sort of the discussions we have to have rather than just simply doing what we've always done and putting the same amount of fertilizer that we've put on in the past. I think analyzing expenditures like that is very important. Maximizing the output of your operation or of your farming. Now that means something different to a lot of people. And if you are the coffee shop guy that goes down to the coffee shop and likes to brag about your yields, that will be how you think about maximizing your output, is by maximizing the amount of products that you can produce. I like to look at it as what's the maximum net income that I can produce, because the net income is what I get to take home and what I get to spend on things that I want to enjoy. Some people will look at what's the maximum gross return that they can generate. And that is either through selling at a really high price or growing a really big crop and selling it at a price. But again, there's a whole other section of our income statement that really affects what we get to take home at the bottom line at the end of the day. And that's our bottom line, or our net income. So for me, yes, I like to grow a big crop, and I also like to sell it at a big high price, but I also need to try to minimize as much to the extent possible my expenses. And when I can minimize my expenses and try to capture as much income as possible, as much gross revenues, I should maximize the amount of net income. So for me, and on our operation, maximizing our output, the way I consider it, is to be my net income. And looking at my bottom line as to, after all the things that I've had control over, have I done everything I can to try to maximize that as much as possible? Knowing your cost of production is very important. A lot of people will talk, and you'll go to seminars and people talk about cost of production. Your costs are going to be significantly different than my costs and my neighbor's costs. We might all farm in the same district, but the way that they run their farming operation is going to be different than the way I run my farming operation. And our cost of production is going to affect the way that I market my grain versus the way that they market their grain possibly. And so understanding what is your cost of production, not generalizing it, is very important. Iron addiction. I told you I still got that 1370 on the farm. That's a little bit of an iron addiction. I could probably sell it, but we do use it occasionally. And it doesn't cost us anything to have on the farm anymore. But trying to minimize the amount of equipment that we have on our farm. And I'm not saying it's a strategy that works for everybody, but on our farm, we like to buy good used equipment. Very rarely do we buy anything new. Having said that, I'll admit I just bought a new skid steer. So we do buy new. But I analyzed that transaction where I could have bought a used one for $30,000 less, or I bought a brand new one that's going to last me for 25 years and have the same amount of hours as the used one had on it. So to me, it made sense to spend a little bit more. But trying to find good used equipment and trying to minimize a cost of equipment, for me, is one of the key things that I like to look at. I like to have lots of equipment and like to have lots of good equipment, but buying stuff that is low cost of operation is important for us. And that's why we're a multicolored operation. We have green, orange, red, yellow. I pretty much have to deal with all of the dealerships in town to go get my fertilizer or my filters at the end of the season. So leasing versus buying. Now this is a whole other presentation that I can spend 2 or 3 hours on, but just to highlight briefly when we're talking about analyzing costs and how to keep our costs down is this a need or is it a want? And I'll admit again with the skid steer, it was probably a want more than a need, but I somehow justified it to my wife and she accepted it, and so we got it. But is it something that you absolutely need to make your operation efficient and profitable? Or is it making just a little bit easier? And there's a lifestyle challenge or aspects of it as well that is important. But is it something that you truly need on your operation, and can you truly afford it? Leasing is 100% tax deductible. So everyone's pretty familiar with that rule. The issue, and what I go into in my in-depth discussion is, yes, leasing is 100% tax deductible, but buying is far more to a tax advantage than it is to leasing. Most times when you ask anybody that's entered into a lease, they'll say, why did you lease that piece of equipment? They'll say, because I get to write off 100% of the lease payments. And I said, yes, I agree. However, if you would have bought it and you took all of the useful life and all of the risks that's associated with that purchase, you would have got a better write-off. And especially with the recent tax changes that have happened in Canada, there's one that's been imposed in terms of increasing the first year deduction for capital cost allowance. Instead of the half-year rule where we take half the normal rate, now we get to double that rate. And we actually get to take 1.5 times the normal rate. So we're getting to write off a huge, significant portion of our purchases in the first year. And it has been announced, but hasn't been approved by cabinet to effectively write off 100% of our capital cost purchases in the year of purchase. Now, they haven't, like I said, it's been announced. It was announced in the federal budget in the fall, or sorry, the federal economic statement in the fall, but it hasn't received royal assent. So you can't do it yet, but eventually it might pass where we could write off 100% of our capital cost purchases. Now, having said that, that all sounds really great. And as farmers, we love write-offs and we don't want to pay tax. So we do everything we can. And so let's go out and spend a whole bunch of money on capital assets and write it off. But through my career and through my years of working with farmers, retiring farmers paid the most income taxes that I ever had to deal with. And the reason that retiring farmers paid the most taxes that they had to, that I ever dealt with, is because they didn't pay it as they went. They did everything to avoid tax. We use the cash basis of accounting, and we can push off income. We can bring forward expenses. We can buy capital assets, take depreciation on it, lease assets. And then when the final years come down to winding up our operation, we've got all this income that we generated, and now we have to pay tax on it. And we're paying it at a significantly higher rates than if we had just paid a little bit as we went all along. Leasing high-use assets, to me, makes sense. So if it's an asset that you want to have the latest and greatest technology, quite often in the western provinces, we'll see sprayers getting leased. It's something that probably goes over the land 4, 5, 6 times in a year, is one of the higher hour units, and technology changes quite rapidly in that industry right now. And so quite often people will say, well, we want the newest and greatest, and we want to make sure that it's available when we need to go out and spray because there's an infestation of some sort or a disease. And so we need to have a good quality unit. And so we'll often see that. Now, releasing a whole line of equipment, to me, doesn't make a whole lot of sense. So just going on to the basis of accounting, and I alluded to it just briefly, the accrual basis versus the cash basis. Both very important to understand, and they have their very distinct reasons as to why we need to know both of them. Now, as an industry, agriculture and fishermen are the only industries in Canada that can file their tax return based on the cash basis of accounting. Every other industry, every other business has to file it using the accrual basis. Now, the cash basis, and we all understand how the cash basis of accounting works, is basically when we receive income, receive payment, that's included in our income, and when we pay for an expense, that's when we get to deduct it as an expense. The accrual basis of accounting is when we earned that income. So for me, when I grow a grain crop, even though I haven't sold it, if I'm figuring out my accrual income, it will be everything that I've got stored in my bins. Even though I haven't sold it, and I'll value it at the price that I'm able to sell it at. And when it comes to expenses, it's when did we incur that expense? When did we use that expense? So if I'm buying chemical right now, I would put it on my balance sheet as an inventory item because it is not being used right now to grow any crops. When I turn around and I use it in the summertime and I apply it on my crop, that's when it goes onto my expense. And maybe I've negotiated a deal with my supplier that I don't have to pay for it until January the next year. From the cash basis of accounting, I don't get to report that as an expense until January the next year, even though I've used it back in September, in the summertime of 2022. So cash basis of accounting, we're going to continue to use it for filing our tax returns. However, we should not be making business decisions using the cash basis of accounting because we're comparing two different situations. And 2021 is a classic example of how we could throw off, or 2022 actually even, how we don't get a true picture of what their costs are. Because we're going to grow a crop and it's going to be valued at whatever we can sell it for this year. But maybe because I foresaw that the price of fertilizer was going up and I saw that the price of chemical was increasing and fuel was going up, so I stockpiled all that back in the fall. So I've got it at lower prices. I get to write it off in the fall time when I paid for it, but I'm not comparing that. I'm comparing that against the crop that I grew in 2021, which I'm going to be using in 2022, those inputs. So we need to be making those adjustments and those analysis based on what did it take to grow a crop in 2022, not what did I pay for my commodities back in 2021. And so that's the important part. When we're trying to make business decisions, analyzing the profitability of our business, we need to use the accrual basis. But use the cash basis in order to file our tax returns. That's why accountants get paid so much money, because we have to understand that and we have to convert from cash to accrual. You guys aren't very funny. You don't like my jokes about accountants. I like to pick on them because I'm no longer that. There's 3 types of financial statements that we need, that I think are important when you're analyzing your business operation. The first is the balance sheet, looking at what are the assets that you have and what are the liabilities that you owe to someone. And what's left over is your equity, the owner's equity. Now, a balance sheet for accounting purposes is based on historical costs. What did we pay for our assets? There's another statement called a net worth statement, where we create basically the same looking type of a statement, but instead of using our historical costs, what did we pay for that asset? We now use what is our estimated fair market value. So we'd go through and we'd value our inventory. If we've got grain in the grain bins, we'd value it based on what's the value today that I could sell it for. If I have inventory, if I bought fertilizer for $400 a ton and now it's $800 a ton, I could effectively sell that today at $800 a ton, so then I would value it at $800 a ton. If we've bought a tractor for $5,000 and now it's worth $7,000, or maybe it's worth $3,000, we would value it at whatever that value is and reflect it, so that when we get our total value of our assets less our liabilities that we owe to third parties, we come up with our true value of what do we have invested in that business. And that's our net worth. Then we have the income statement, and everybody's familiar with the income statement. That's the statement where we looks at what did we earn and what did we pay and how much income did we make? What did we get to take home? What was the profitability of our business? And the final statement is a statement of cash flows. And the statement of cash flows basically shows where did we spend our money. Whenever I would sit down with a client and we go through their financial statements, they'd right away breeze over the balance sheet. They didn't want to talk about that. There was 2 numbers that they only cared about. And the 2 numbers was, how much money did I make and how much tax do I have to pay? And it depended on the client which question got asked first. So you'd go down to, you'd say, okay, well, how much money did you make? Let's go look. And we go to the balance or to the income statement and say, okay, you made $422,000. And the wife would say, well, where is it? If we made $422,000, where's the money? And I said, that's a great question. Flip the page and look at the statement of cash flows. That's going to tell us exactly where the money is. Because we start off with $422,000 of net income. And then we adjust it for our payables and receivables, where we spent our money, where we got it. And then we go down to financing activities. Oh, we spent $325,000 on a new tractor. We spent $200,000 on a new combine. We spent $300,000 on a new air drill. And then we go to financing activities. And we paid back $100,000 in debt, but we only took on $400,000 of new debt. So we spent $400,000 of our cash that we made in our business on capital assets. And that's what that statement will tell us. That'll show exactly where did our money get spent, divvied up between the financing activities and the investing activities. So it's a very good statement. If you haven't, some accountants don't prepare it because normally the clients don't want to pay for it. But really, it's not that hard to prepare, and it can provide really good information and a really good analysis going forward. And the bankers really love it when you have that statement because it makes their job a little bit easier as well. So here, I want to talk about the impact of rising prices. And I just kind of picked a few of the different expenses that I thought maybe we had a little bit of control over and that we've seen some of the larger increases on. The first one is fertilizer and UAN. We use 2800 on our farm. I paid back in the fall 47 cents a pound. And when my supplier phoned me, I said, I was mad as hell that that's the price. I said, this is way too much. It's more than we paid last year. Why are we, it'll come down. Well, he didn't listen to me, thankfully, and he booked enough product for our whole year. And now I'm thanking him, saying thank you for booking that all, because now it's $1.37 a pound. So we've seen 191% increase over 2021 to 2022, just in UAN fertilizer. And there's phosphate is very similar, and it continues to escalate, keeps going up. Another one that I looked at is glyphosate, and whether you can get it or not is sort of the question, but basically they're at full MSRP prices. Everyone's advertising it at, and that's $10 an REL or Roundup equivalent liter. Last year we paid $3.80 for that same product. It did exactly the same thing, so that's a 163% increase. Fuel, last year our average price on our farm was 90 cents roughly. Now it's $1.45 and seems to be going up every day as well. Interest rates, fairly minor, but I think this is something that we need to start watching and looking at. Last year was 2.45 was the prime lending rate. Right now it's at 2.75. It's or 2.7, sorry. I'm expecting, and I think most people are expecting, that we're probably going to have another 25-cent basis point increase before the end of the year, probably even maybe more than that. I've just said that we're going to have one more. So we're looking at roughly 3% interest, which again, very, very good rate, very low rate, but is going to start increasing substantially. My first loan on that tractor and combine, 7.8%. Part of the reason why I lost sleep, because I'm thinking how much interest I'm paying. But I made it, and there too, that wasn't a bad rate. It's just that we've been very spoiled with very low interest rates, and I think that's coming to an end, and we're going to see things change. And then the carbon tax, as of April 1st, it's going up another $10 a ton, so we're going from $40 a ton up to $50 a ton. And the CFIB estimated that carbon tax is costing, and this is just an average of $28,000 on a farm, on the average farm per year. So that's going to go up to $35,000 starting on April 1st, roughly. And again, that's just an estimate. So what I looked at is, how much fertilizer are we putting on? How much is this all going to cost us in extra costs? So 200 pounds, assuming 200 pounds of nitrogen that you're going to put on your crop. Last year would have cost you $94 an acre, still significant a number, but this year is going to be $274. What I'm really now starting to think about is how much are mistakes going to cost me? When I go out there and I finish seeding a quarter section and all of a sudden I realize that I've put 5 pounds of nitrogen more than I wanted to because of something was miscalibrated or wasn't set quite right. Before, well, it sucked, but I had a little extra nitrogen, cost me a little bit more, but it wasn't that big of a deal. That 5 or 10 extra pounds in this case is going to be an extra $13.70 an acre. I think a significant increase over what it was. It was $4.70 before that. Glyphosate, I'm just using an estimate on that. Our farm, we're probably using 1.5 liters across the farm, more certain years on certain crops. That used to cost us $5.70. Now it's going to cost us $15. So an increase of $9.30. Again, you used to be, you had the Roundup pump, and if you got busy on the phone or something like that and you put an extra 10 liters in, well, it didn't really matter. You're just going to kill the weeds even a little bit better. Well, now we're going to make sure that we're watching and calibrating our equipment much closer, because that extra 25% is going to go from 95 cents an acre up to $2.50 an acre, and higher if we make more mistakes than that. Fuel costs increasing. I'm saying I roughly figured it out. On our farm, it costs about 2.5 liters per acre per pass. So that's $2.25 last year it cost us. It's going to be up to $3.63 an acre this year, or an increase of $1.38. If we make a mistake or something goes wrong and we have to make an extra pass across the land, that's going to cost us $3.63 as well. So it's basically increasing it that much more. And then interest rates, again, not a significant amount, but those we're going to start to see, I think, as interest rates keep climbing to combat inflation, is going to be more of a higher number. I remember doing tax returns for people and financial statements where they'd have $200,000 of interest expense on their financial statements. And this was at rates of 2.5%, some of the lowest rates we've had. And I think if that rate doubles, that $200,000 becomes $400,000. Takes away all the profitability that they had. And it's gone to 5%, not an astronomical rate, not the 25% or 22% that they talk about in the 80s. This is just going back to a normal average rate of 5%. So I really think leverage on farms is going to be very important going forward, because as we see interest rates increase, and the other thing that we need to be talking to our bankers and our financiers and our suppliers is how much line of credit do we have? Because if my fertilizer cost is going up by 191%, my $300,000 line of credit isn't going to cover it. I need to have a $600,000 line of credit, or maybe more. And we're not going to see that probably until the summertime. But right now is a lot better time to be sitting down with your bank or talking and going through what are my cash requirements going to be for this year, and how much, and having more than not enough, so that hopefully you can take advantage of if there are any buying opportunities, and that you're not scrambling to pay bills because the supplier needs to get paid. So we're going to be into this whole new era of the way of another step. And like you, I'm looking at, you know, canola at over $20. I locked in some $29 canola the other day, like unheard of. I sold one load in my 25-year career at under $5 because that used to be the base. You never sold under $5. You just locked the bins and you held it. But I'd done a basis contract and I'd hauled it in, and I had the basis was coming up and I couldn't roll it, so I sold it. It was $4.90. And now I'm selling it at $30 just about. But so we're going to be able to combat this. And I mean, if the prices stay there, these high prices aren't going to affect us as much, but we got to worry about what's the cost of errors, because now everything is magnitude by so much larger than it was before. Protecting your investment. We only get one chance a year to grow a crop, and making sure that we maximize the profitability from it is very important. So making sure that we're doing it in a timely manner. I talked about the need versus want of capital assets. Well, if getting your crop off out of the field in good condition, in a faster timeliness, and saves on drying costs or marketing costs or whatever that might be, then it becomes, that capital asset becomes a need. Because if we can derive more value, even though, yes, we might be able to get it done over the regular time period, but not always. If we can capture some premiums by doing it in a more effective manner, then that's where we're going to save, and we're going to provide more value to our operation. As the accountant in me, as I said, I always analyze all of these type of investments. And about 7 or 8 years ago, we bought a different air drill. And I had looked at it about 5 or 6 years prior to that, sectional control on our liquid fertilizer application. And at the time, it was probably $7,000. And I thought, geez, you know, I just don't think I'm going to pay for it. And you know, looked at some of the analysis and talked to the salesman, and they said, yeah, no, it's like a 2.5 year return on investment. So you'll get your money back in 2.5 years, roughly. And I decided, you know what, no, let's not do it. The next year, air drill comes along 7 or 8 years ago, and it's time to look at it again because we need to put a liquid kit on this one. Now the price has gone to $12,000. Price of fertilizer has gone up. Bigger, wider drill, so makes a little bit more sense again. But they're still kind of giving me that 2 to 2.5 year payback. And I finally said, okay, you know what? Maybe like 12,000 really in the whole grand scheme of things isn't that much. And then you start buying into the 4 R's in terms of fertilizer placement, and we were over applying on the headlands. Always was where our issues were. And you might picture Saskatchewan as big blocks, and there are areas where there's big blocks, square 160 acre fields. I only have about 4 of those. The other ones have creeks running through them, or there's a yard site, or there's something, so it's always jagged and crooked. And so I made the decision, we put the liquid kit on our drill and went with sectional control. My brother is in charge of bringing me the fertilizer. I'm in charge of ordering the fertilizer. And usually when we get down to the last few days of seeding, I have to phone the supplier and say, okay, we're ready to take the last of our product that we booked with you. You can bring it out. So I sent a text, or I rated my brother, and I said, when you fill up the liquid fertilizer truck this morning, check the level on the tank, because I think we're going to have to get Rick to bring us some. And he says, well, no. He said, we still probably got 2 days worth in here. And I said, what do you mean? How, like, we got to be running out, because we're always run out at this time. And he said, well, I don't know unless it's wrong, but that's what we've got. So we waited. It turns out that investment that year paid for itself at about 75% of our seeding. At about 75% stage is where I'd already saved $12,000 to pay for that investment. So the moral of the story is be hard and analyze your investments, but don't be too cheap as well. Like, think about it and learn from your mistakes. So now when we're doing it, you do more in-depth research and figure it out and see where does it really make sense. I'm really struggling with, the newest and latest technology now is seed and fertilizer sectional control on your whole drill. That's going to be about $100,000 to $120,000 investment, and I really struggle with that being profitable on our operation. But as seed costs go up and fertilizer costs keep increasing, the people that probably adopted that technology before are going to have it paid for itself fairly quickly. So continually analyzing those sorts of investments, I think, are very important. Is there an opportunity to use custom services? As farmers, we usually like to do everything ourselves and have control over everything ourselves. And if it's in our shed, then we know we've got it and we can use it. But are there certain aspects of the operation that we can let somebody else do and that we don't want to be involved in, or that they're more efficient at doing it? One of them is we float on some fertilizer in the fall time, and that's one job that I do not want to get involved in, because they've got the technology, they've got the asset that they need to, they've got far better technology and assets that they can use because they're going over a lot more acres than what I would on my operation. And yet there's still farmers, and reach their own, but there's farmers that are doing it themselves, and I just don't see the value in that, for us anyway. Two final things, and then I'll wrap it up. Business meetings. Two types of meetings that we think we need to have on our farming operations. Business meetings are a meeting where we have everyone involved in our operation. Not necessarily our employees, but all of our owners, family members that are involved, spouses, children if they're involved in trying to make the business decisions on the operation or learning from you how to make business decisions. They all need to be at these business meetings. And how regular we have those business meetings is going to depend on you and your operation, how many people are involved. Some people have them weekly, some people have them monthly, some people have them quarterly. At a very, very minimum, they should be happening at least once a year. If you've ever invested in a public company, you'll get a notice of an AGM, an annual general meeting. They're having that one business meeting a year at a minimum. So your business should at least have one where you're going to discuss the financial statements, how much tax you're going to pay, what your seeding intentions are, buying, capital investments, all those things. Maybe you're just looking for input or informing the other people because those are decisions that you're making. But having that discussion and formalizing it in a meeting where you sit down and that's all you discuss. You shouldn't be having it at family gatherings or holidays or in the shop. It can be in the shop, but it needs to be away from the work area and dedicated on looking at what is it that you're learning, or what are you trying to get to accomplish through that meeting. All those financial statements that I talked about, so going through those. Maybe you have your accountant there to go through them as well. Maybe you have your agronomist there to talk about what agronomy things are you going to be doing differently this year, or what are you going to adopt in terms of making your operation more successful. And then also planning out and just determining roles, whose roles and responsibilities, planning out the work, the tasks that need to get done. Those are all things that we would be discussing in a business meeting. And the final one is a family meeting. And the family meeting is where all the family members are involved. Because I'm sure you heard it, there's a huge transition issue, not only in agriculture, but we seem to see it more in agriculture. And part of the issue comes with the unopenness of discussions and the lack of family meetings and the lack of discussions. So having a family meeting involving everybody that's involved, some will say, does that include the in-laws or not, the spouses of our children? That's going to depend on your family culture, whether you want to include them or not. But explain to them, what is it, how are we running our operation? Do we have a partnership? Do we have a joint venture? Do we have a corporation? Who owns what? Who owns the farmland? And then talk about what are the implications on a death and the wind-up. Who's going to take it over? I don't think there should ever be a will that's a surprise to anyone. Or there should be a will that's very general. Lawyers love to make general wills. Do you know why? Because there's more fights with a general will. And who makes more money in a fight? I like to pick on lawyers too, even more than accountants. Be very specific and let everybody know exactly what they're getting. If you're not letting them know, why are you hiding that from them? Why can you not tell them that? You should be able to explain and justify all of your bequests in your will. And then it's just a matter of a formality after your death to go to the lawyer to find out, okay, this is what we need to do. These are the assets that they had. And it's done. Because if you're leaving certain assets to one child to the exclusion of the other, well, why? You must have some reason for that. Is it because you paid for an education of one that's not on the farm and the other one stayed on the farm to help you? Is the only way that the farm is viable if we leave it to one child? Are there payment options, transactions? All that information can be discussed and explained. Asking them what is their, what do they want? What do they expect? What are their expectations? They might say, you know what, you've provided to help us with a down payment on our house. You've given me an education. I want Johnny or Jenny or whoever it is that's on the farm to be able to run the farm, and I like the fact that we can come back to the farm. I don't expect anything from it. Or the next family culture say, no, I want my fair share. I get an equal share in it. That's going to dictate what our culture tells us. But having a meeting like that, it's not going to be an easy meeting. It's going to be probably an uncomfortable one. How often you have them again, I don't know. That's going to depend on your family and how you get through it and changes that occur. But having a family meeting like that can hopefully solve a lot of fights and problems later on and expectations of what was actually going to be theirs or not theirs. So just the tips, keeping your costs under control. Analyzing. Remember, there's two aspects that make our farm profitable. Gross revenue and our minimizing our expenses. Both of those contribute to how much profitability we have on our farm. So keeping control of the cost, not ignoring them, but looking at those. Focusing on every aspect of your farm. There's certain things that you're good at and you're not good at. Obviously, I am very focused on the financial aspects of our farming operation. Agronomy is an area where I need help. I need to hire somebody because I don't know. I try to learn and I try to understand, but I don't have the technical knowledge that an agronomist would, that has studied that and works in that every day. So what are you good at? Focus on that and make that the most for your operation. Minimizing your taxes, minimizing them, not eliminating them, and minimizing them over your whole life of your operation. Not just this year. Don't focus on this year, because if you keep focusing on minimizing your taxes and not paying any taxes right now, trust me, you're going to be in for a big ugly surprise at the end. And I've heard all the stories of a drought's going to fix that, and I'm going to be dead and it doesn't matter, and on it goes. But at the end of the day, the operation pays far more than it should have. Branding your farm, make it stand out. Build those relationships with your customers so that they want your product, they know what you're going to get, and they want to do business with you. Be a good customer to them, or be a good supplier to them. Avoid the iron addiction of buying and continuing adding pieces of equipment only if they make sense. Budgeting and planning. Going through those, analyzing those costs like I did. I've just picked a few of them and went through them, but looking at what does a mistake cost us now compared to what it did in the past. And how much just putting an extra 10 pounds of nitrogen or another pass with our tractor, what's that going to cost us? Because those costs continue to increase. And if you work smart, if you love what you do, you don't have to work ever. You enjoy what you do. There's aspects on the operation that I don't like, but I tell everybody I don't work anymore. I quit working in 2012 when I quit my job, my accounting job, and I love doing that as well. But I love farming that much more, and it's something I thrive and I enjoy, and obviously you can see the passion for it. So, thank you very much. If there's some time for some questions, if anyone has any questions for me.
Yeah.
If not, I'm standing between you and lunch, so that's never good.
Who's got questions for Lance? Any questions? Yep.
Thanks very much, Lance. I just, it's something I've wondered over the years is how many times a year would you say you actually sell commodities off your farm? And how many times a year do you price crop inputs? And how should that change in the future?
Well, yeah, pricing inputs is probably once a year. In terms of, fertilizer, I'm thinking about that, or even chemical. In the past, it's always been, I'd kind of go to my 3 main suppliers for chemical. Fertilizer, we've come down to a relationship with one supplier he just provides everything. And commodities are marketed monthly, probably. It should be. We're doing that a lot more. I think as prices continue to rise and supply becomes more, if it continues to be an issue like this, we need to change our focus in the way that we are purchasing our inputs. And, we're maybe hedging off 10% of our fertilizer costs and 10% of our inputs. Maybe we buy 2 years worth. I don't know. It's all going to depend what that crystal ball tells us. But I think purchasing inputs got to somewhat reflect how we're going to market our grain. I think is going to change.
And if some of the numbers we've been looking at, when you look at all the increases, if you compare the price of commodities today versus input costs, and if we look back over the last 3 years, are they that much different? We're seeing the extremes on both sides.
Right. No, I think at the end of the day, right now, I'm very excited about 2022. I think I have an absolute, if commodity prices for us can hold where they are, this is the 1970s. This is where equity is going to get made because we've got a lot of inputs pre-bought at lower prices. And there's a huge opportunity, I think. But we need it to rain is one of the risks for us. Unfortunately, we don't have the irrigation. I was so jealous when I hear, well, you just turn it on. We were trying to turn it on all last June and July, and it never got turned on. Anyway, I think I don't want to sound pessimistic because I'm not. I think this is but risks have gone that much higher. I had an old farmer tell me years and years ago, he said, I farmed for 40 years and my profitability hasn't changed. He said, when I started farming, I made $5,000. I put $40,000 through my bank account. I got to keep $5 at the end. Now I put $400,000 through my bank account and I get to keep $5,000. And I think that's probably where, those aren't real numbers, but that's where we're going to be. Profitability is going to settle out and it's going to shake out. And we're not going to be, just because we're able to sell our commodities at high prices, and yes, we're going to complain about the high input costs, we're probably not going to be that much more profitable unless we do some really good buying and some good opportunities. But commodity prices, things are going to change in the world that might bring commodity prices down. The part I struggle with is the non-farming people looking at it and they hear the news that, canola's at all-time highs and wheat's at all-time highs, and then they own farmland and then they want to rent their land for all-time highs. And that's the frustration that I have is, yes, I'll agree that I'm selling my commodities at a higher price, but and my rent should probably go up as well, but to what extent?
Any other questions? We got time for a couple more questions.
Not if they're as long-winded as that. Oh, don't ask that. Don't. No, yeah, no. You can buy land for about $2,500 an acre, and rent is about $50 to $100, $120 an acre. Now you'll say, boy, that's cheap. And it is. We're one of the cheapest areas. But I've traveled from coast to coast to coast, and I've realized that where I farm is one of the toughest places to grow a crop in terms of frost-free days. Last year at the end of seeding, we got 6 inches of wet snow, which didn't hurt the crop, but didn't do it any favors. And typically our first killing frost will be around that first week of September. So we're very limited in terms of the crops we can grow and the time that we can grow it in. So land prices have a value based on the profitability of that land, and I've realized that. I was up in the north of the Peace, it's 150 kilometers from the Northwest Territories border. I spoke up there. When they sent me up there, I said, "There's agriculture up there?" I thought that's only where Santa lived. And they can grow a crop faster up there than I can grow it in central Saskatchewan because of daylight hours. During June, they've got 22 hours of daylight, And if they get just the right rains, they'll get the crop a lot quicker. They'll be combining before we will. They'll get seeding the same time as I do, and they'll be combining before we are.
Any other questions?
Nothing as personal as this one.
Well, Tobin says it.
I'm just teasing.
Could you just speak a little bit to the tax rules on why those farmers retiring were paying so much tax when they were putting it off all those other years? I'm just not a tax expert, but thanks.
Can we get lunch delivered? No. Just really quickly, because it's the cash basis of accounting forces us into it, or doesn't force us, it allows us to do it. And, they just always want to minimize their taxes. And I get it. I mean, maximizing our cash flow is very important. And I started in 1994, and it wasn't only until about 2014 that I finally felt that my head was above water. Otherwise, it was like, how do I revolve my line of credit and put this expense on a credit card and pay that? And every piece of equipment that came onto the farm had a debt associated with it, to where we've finally been profitable now the last few years, where it's like, okay, finally, like I've got some cash in the bank. I feel good about it. And so maximizing the amount of cash, the farmers looked at what's anything that we don't have to spend it on. And so right away it became taxes. Well, we'll just defer that grain sale, we'll pre-buy inputs, we'll do whatever we can, and we'll pay that tax when it comes. And we're one crop failure away from all that tax problem going away. Well, we've had several crop failures, and I won't say failures, but reductions, and that tax problem, yes, it sometimes shrinks, but it never goes away. The other thing is buying capital assets. They buy capital assets, depreciate them up until, and right now, the way inflation, I mean, just going back to the skid steer story, the reason I bought the skid steer, and my wife laughed at me and said I'll never do it, but I said, I can buy it today for X amount of dollars. The way things are going, I can use it for a year, and if I decide I'm not going to use it, I can sell it for probably more money than what I paid for it. So it's really not going to cost us anything. So as we see equipment prices keep escalating, we're able to take a motorized piece of equipment, depreciate it at 30% a year, 45% in the first year, say $200,000 tractor or combine or whatever, write that off $90,000 the first year. Well, that combine or tractor didn't go down $90,000 in value. Now extrapolate that sort of calculations over all of your equipment. So now what we've got is recaptured capital cost allowance. So we've written our equipment values down to, let's just say, $200,000. And you phone the auctioneer and you say, I'm going to retire next year. I want to have an auction sale. Come value my farm. What do you think I can get? And they come out and they say, well, you can get $700,000 when we have our auction sales. What you're going to net. Well, that means on your tax return for that year, you're going to pay $500,000 or income tax on $500,000. Plus, you've probably stored a whole crop year that you're not going to put in the next year, so you've got no expenses against it, and now you're going to sell that crop in that year as well, or maybe over the next year, something like that. But it's building that balloon up and not managing it. Like I strongly believe, and it sucks. Trust me, I know, because I'm now sitting on the other side of that desk. I've told my clients years and years, I said, pay tax. You got to pay a little bit as you go. Don't pay more than your fair share, but you got to pay some. Now I'm on the other side, they're paying it, and I'm like, Jesus, sucks, but I know it's the best thing, because at the end, I'm going to have hopefully a big portion of my taxes sort of dealt with, and I'm not putting that burden on the next generation if they decide to take it over, or have that big hit all at once, because we have graduated tax rates in Canada. Our tax rates continually go up the more money we make. So if we can utilize those low brackets and those low income taxes, then we're going to pay less tax overall. On a personal level, I think, and I'm doing it, I'm paying tax on $100,000. Even though I don't need $100,000 to live on, my wife and I are both paying personal tax on $100,000 because I'm using those bottom two tax brackets up. Those are the lowest tax brackets. And if I don't use them this year, they're gone and I can never get them back. I deleted 2 slides out of there, exactly that, so I'm sorry. You got them anyway.
Anything else? So thank you very much, Lance. That was a terrific presentation. I learned a lot. I'm sure a lot of other people did too.
Thank you.
Just want to inform you folks about lunch. And yes, thanks so much, Lance. Great tips for management and maintaining profitability on the farm. Some new ways to look at things too. So there is no lunch. COVID everybody knows there's no lunch on the trade show floor this year, but there is, Red Shores is right next to us here, or alternatively, you could go downstairs to Turf's Bar and Grill. They've got sandwiches, quick bites to eat and things like that. Of course, the trade show is now open, so enjoy cruising around there this afternoon. And we're back here again tomorrow morning, right at 9 o'clock. Enjoy the rest of your day.